Good afternoon, ladies and gentlemen. It is our honor to welcome you to FC Kohli Day 2023. I'm Nanda, and this is Orgo, and we're your MCs for today. The Kohli Center on Intelligent Systems commemorates the birth anniversary of Shri FC Kohli with a special program celebrating his life through nurturing research and innovation.
Vakil Chand Kohli was a co-founder and the first CEO of TCS, the Tata Consultancy Services, India's largest software services company. He was also associated with other companies within the Tata Group and had been president of the Indian IT Services Advocacy Body, NASSCOM. He was a recipient of the Padma Bhushan in 2002 for his contributions to the Indian software industry. He is referred to as the father of the Indian IT industry for his contributions to the establishment and growth of the Indian IT industry.
This year, as we transition back to an offline and larger celebration on the occasion of Kohli Day, we have a lot to look forward to this evening with many incredible sessions ahead. To get started and to extend a warm welcome to all of our guests gathered today, I invite the director of the Institute, Professor P.J. Narayanan, onto the stage to address the gathering.
Good afternoon and welcome to third FC Kohli Day that we have been celebrating. We are sitting in the Kohli Research Block. We are all part of the Kohli Center on Intelligent System. It all happened in 2015 or just before that when TCS Foundation accepted our request and said we would like to set up something that has a research focus as well as has Kohli's name on it, and both were sweet music to our ears. So we proposed the intelligent system. We didn't want to call AI because I think AI has become a big buzzword in the media, but I think most academics stay clear of the word AI if possible. So we broadened a little bit. Our strength was in broad AI kind of areas, so including robotics, computer vision, NLP, data sciences, cognitive science. So we said, called it Kohli Center on Intelligent Systems, and the building was completed and was inaugurated in January 2017. And so we had before that in 2015, we had a foundation stone kind of laying kind of ceremony in which Mr. Kohli and Mrs. Kohli came. And then next, a year and a half later, after the construction is over, 2017, January, Mr. Kohli came. And I remember when he came in 2015, it's the first time that I've seen him on this campus. So I asked him, we would like to invite you, please come to our campus. He said, I will come as often as you will invite me. And that's what happened. He came at least 3 more times until he passed away in November 2020. So I think we feel very close to Mr. Kohli for some reason. Of course, the entire IT industry and all of us owe a lot to him to make this IT industry happen, and which changed the image and fate of India in many ways. So I think it's only right to honor him. So his birthday is March 19th. This year, since it's a Sunday, we want to hold it here on a Monday. And we have been doing this, last 2 events were obviously online. This is the first physical Kohli Day that's being celebrated. I'm very glad about doing that, but it's also in online. So we have several events, as you see, a couple of great talks that we were able to line up, both Professor Subbarao and Professor Subramaniam, the Maryland Mafia, as I recall. I graduated from Maryland. Rao was a student, and VS came as a faculty. So it's the Maryland Song and Dance Show today. But we have an interesting panel that you will hear about after this. And we have this is an innovation that we tried for this Kohli Day, the Faculty Alumni Interaction Day. One faculty and an alumnus who's doing well somewhere else typically elsewhere in the world. And we have a 15-minute kind of conversation recollecting, what their days here or whatever. And this time, for the first time, the middle guy, Ishan Mishra, is my student. So I'll be doing this side of the of that conversation. He's in New York, so he will not be here live. So I'm very glad. I don't want to take any more time in welcoming. I just welcome all of you who are here or online, and I'm sure you'll have a fantastic day. And I'm glad to see, Anant and Harry come also from TCS Foundation. I'm TCS this time to the first physical event. So I called them 2 days ago. I called Anand 2 months ago, and he said, he will put this on the calendar and come. In fact, he also got VS here. So that's a double benefit. So thank you, Anand, for that. And over to you to the actual event. Thank you very much.
Thank you very much, Professor. Now, in order to introduce our keynote speaker for this evening, I call onto stage Dr. Hari Kumar Kandat.
Good afternoon, everyone. It gives a great pleasure for me to introduce Subrao, our distinguished keynote speaker, Professor Subrao Kambapati. He's a professor in Arizona State University, and he studies fundamental problems in planning, decision making, motivated by challenges of human-aware AI systems. He's a fellow of Association for the Advancement of Artificial Intelligence, American Association for Advancement of Science, and Association for Computing Machinery, and was an NSF Young Investigator. He served as a president of the Association of AAA and a trustee of International Joint Conference on Artificial Intelligence. And he is a founding board member of Partnership on AI. His research as well as his views on its progress and social impacts of AI have been featured in multiple national and international media outlets. With this, I welcome Professor Subrao to deliver the.
Okay, and then this one goes back. Okay, thank you all for coming, and then thanks PJ for inviting me. I feel as if I'm like an affiliate faculty member of the IIIT, and it's always great to come here. And before I start, I also want to say that it's always intimidating to have to give a talk in front of your own teachers, and Ignarana Garu is the person who taught me AI, and he's there. So I'm so happy that he showed up, but I'm also going to be nervous. So okay, so I am going to talk to you about this beyond nodding and pointing, widening explainable and advisable human-AI interaction. What do I mean by that? Okay, so you guys are all talking about AI systems these days, and they don't behave, and they don't when they make a decision, they don't tell you why they made the decision. When you ask them to change their behavior, it's a very slow process. In particular, the way what has become dealing with AI systems has been explanations by pointing. So if you ask an AI system, why is this a dog? First of all, I don't quite know why people ask AI systems why something is a dog. But if you do ask it, then the best it will try to do is to show the saliency regions, the parts of the pixels that seem to have had a bigger influence in making that label come to be a dog. We'll talk about how saliency is some idea, but on the other hand, actually pointing is the most primitive form of explanation. Human civilization invented a lot more than just pointing, but we are stuck with that as explanations from AI systems. On the other hand, if you're trying to advise the AI systems, you know that the GPT-4 and ChatGPT, as egregious as they are sometimes in their completions and their racist, sexist, yet factual completions, they try to make them slightly better by essentially human feedback. They have this RLHF, reinforcement learning from human feedback. There's a question as to whether RL is actually needed or whether the human feedback is the signal that's added on top of the pre-trained model to just change the weights. But either which way, you are nodding, okay? You're being shown two different answers to the prompts. And since you have no life else other than to train ChatGPT, especially if you're being paid poorly in Nigeria or something, you're being shown these two essays and you say, yeah, this is right. Yeah, this is right. And so in which case, these nods until your head falls off will become the loose signals that are used to train these systems to behave better. I know that once in a while we nod to our kids, but we talk to them. We actually advise them. And so what do we want to do? What we want to do is we want to have AI systems that are actually easier for humans to use, machines which will provide explanations, not by pointing, because pointing doesn't even work. If I'm asking you, if you ask me, Rao, why the heck did you come 1 full week back when your talk is today? I have to give you an answer for that. But to do that, what am I going to point to? I have to point to a video of my life, a sort of a space-time signal tube of my life and say, look, these pieces, these pieces, these pieces. At which point you'll realize I should never ask Rao for explanations because it's going to be very boring. We instead use abstract linguistic explanations for those kinds of scenarios. And similarly, when advice, we want to be able to give advice in ways that are easier for humans. We tend to do things in symbolic terms. And so advice as well as explanations should be allowable in symbolic terms. And the big point I want to do is just because that has to be in symbolic terms doesn't mean that the AI system's internal reasoning has to be using old symbolic reasoning techniques. I like symbolic reasoning techniques, I've done them, but you want to use AI systems that are actually using some other sorts of deep reinforcement learning from pixel space or something, that's completely fine with me. You can do your reasoning any which way you want. In fact, I have no idea how most of you do your reasoning. I don't know what happens in your heads. But when I talk to you, you don't point, you don't grunt, you use language that I can understand. You use symbolic explanations. And I want the AI systems to use symbolic explanations and take symbolic advice. That's the basic gist of what I'm trying to do in my research. And I'll tell you how we will do it and how to, and some of the work that's been going on in my lab in trying to make that happen. Okay, that's my basic point of it. So anyway, my research background, most of it is in human AI interaction of late, but I started in planning and decision making. And then I also, as people mentioned, I spent a bunch of time, since everybody is an expert, and since I'm actually an expert because I took Professor Ignana's course way before AI was cool, okay? I tell people that I was in AI before AI was cool. So I keep trying to explain to people things that my perspective on AI. So I've written a bunch of these articles that might be of interest, including the changing nature of AI research. AI used to be an engineering discipline, but now AI has become whatever OpenAI has released last week and try to poke it and see what it does. So we become sort of ersatz biologists. Biologists basically take rats and cats and whatever funny animals they'll find and poke them to see what it does. That's what AI is becoming to some extent. And, I talk about that. I also wrote a thing on ChatGPT, since everybody should. And I gave a talk on generative AI revolution, what happens to our reality when AI can spin many synthetic realities. I'm sure many of you wish that I would talk about that rather than whatever else I'm talking about today. But, that is a different day's talk. We basically, an interesting bunch of things can be talked about in, the misunderstandings about LLMs, that exist even on the research scholars that are sitting here, because we are all essentially collectively deluding ourselves on certain things. They're impressive achievements, but we need to be careful about how we use them. One thing I do want to mention is people keep saying that LLMs or large language models sometimes hallucinate. No. They always hallucinate. Sometimes their hallucination happens to align with your reality. And then you say, wow, that's nice. Okay, it's like astrology. Astrology says random stuff. Sometimes it happens to be what happened. You give it credit. When it is wrong, you'll never care about it. So that's why astrology is alive and well, because the denominator is never going to increase, even if it's wrong. So in terms of LLMs and reasoning abilities, that is very much the case. We actually have a paper showing that large language models cannot even provide a 3-block stacking plan. Okay, if I put 3 blocks in one configuration, want it in a different configuration, and they have to just come out with the sequence of moves, they look like sequence of moves. But if you actually try to execute them, the plan will fail because there was no real reason to believe that the reasoning would have happened anyway. So we actually show that about 3% of the time, which is way less than what is allowed by even just the statistical noise, they tend to be correct. Most of the time, they're actually wrong. But that doesn't mean that they're useless. They're actually useful in the following sense. They can give a plan that can be used as a heuristic guidance for somebody who actually knows how to do planning. You ask your friend, hey, guy, I'm stuck. Can you give me an idea? And they give an idea. Even if that idea is a bozo idea, if you can use that idea, you're happy. You can change it. And you know what your problems constraints are, and then this heuristic guidance can help you. And that's a way of actually using LLMs that I believe is a much more reasonable thing. Have human in the loop when you're using LLMs for whatever thing that you're doing. Okay, so that's something that I just want to mention on the side. There's a bunch of things about that. If you're interested in that, you can read that paper. Again, the talk for today itself is this 3-part thing. I want to talk about, because after all, I'll talk about explanations and advice. I want to talk about first, even though I'm not a psychologist, but everybody, computer scientists are supposed to be psychologists, anthropologists, everything, because we have computers. So I act like a psychologist today and tell you what do people do when they exchange explanations in general. Okay, so kind of some higher level points. And then we talk about how we use that as an inspiration to provide an explanation framework for AI systems. First, in the case when the AI systems wind up doing search with basically symbolic reasoning methods. And then in the third part, we extend that to talk about scenarios where the AI systems don't do symbolic reasoning methods at all, but yet they give the explanation in methods in the same symbolic means. That the point, again, as I said, is I don't know how you think, but you need to make sense to me. You should not. I personally feel that if, in fact, the whole promise of AI systems is that whenever we are not happy with what happened, 176 billion parameter large language model, you stop doing what you're doing and try to go through all the weights to see which weight is the bad one, have a life. This is not what we're supposed to be doing. The system should be helping us, not us debugging them. And so I want the explanations and advice themselves to be in terms that we can understand, and I'll talk to you about that in the third part. Okay, so the first part. So how do humans exchange explanations? First of all, there is a pointing and tacit explanations. Little kids, we have no language, essentially just point to things that they want. And if you ask them, who threw that bottle, they'll point to their brother, because they don't want to take the blame. So that's the explanations that they will start with. But pointing explanations are essentially very high bandwidth, because especially, as I said, if I'm talking about an explanation for a sequential decision as to why did you come 2 weeks back, or why did you take this particular flight, why did you use this decision in a sequential decision scenario, it's no longer an image you're talking about. You're talking about a space-time signal tube over which you need to point to the regions that are relevant. And that is a very high bandwidth, cognitively high overload thing. And to some extent, I can argue that maybe, I don't know, I wasn't there when the cavemen and cavewomen invented language, but they must have gotten sick and tired of exchanging these explanations over space-time signal tubes. And they said, hey, let's just start having language. The facetiousness aside, symbolic or explicit explanations tend to be essentially in symbolic terms, which are abstractions over space-time signal tubes. Okay, and language essentially is an abstraction over these signals. And we use that a lot more. And typically, pointing explanations are used for tacit knowledge tasks, the tasks that for which we do them, but we don't know how to do them. So, for example, if you ask me, how do you swim, Rao? It's extremely hard to explain. I just have to show you how to swim. Whereas on the other hand, if you ask me, how do you play a chess, I can give you exactly the procedure that I use to play chess. And those are explicit knowledge tasks for which we tend to use explicit a language-based explanation. And one of the funny things is we are such linguistic animals that even for tacit knowledge tasks, we tend to use language. We have New York Times food critics who describe how food is. What a sad life, essentially. I mean, that's what LLMs do, for example. They have never tasted a mango, but they can write you 3 or 4 page essay about how mangoes taste. Okay, you can do that. But what's interesting is, and similarly in cricket is as tacit as it gets because there are a few rules, but mostly it's all physical motion and so on. You have these crazy concepts like leg before wicket, which only the godly umpires know and the rest of us complain about, right? It's a concept which is actually you're putting a symbolic term over a purely tacit knowledge task. And we actually do this. That's how language evolves. Keep that in mind. So why do AI systems have to give explanations? They can use it in multiple ways. First of all, people tend to use explanations in symbolic terms. Those of you who have already heard of these things like chain of thought prompting. Chain of thought prompting is self-explanations at certain level. Okay, so you can use internal explanations as for yourself. You can I'm mostly interested in using external explanations, in particular external explanations to humans in the loop, because you can give external explanation to other systems. And I think that half-life time for that is too low because eventually all systems will have like a hive mind. And so there is no real reason why systems have to talk to each other the way we talk to each other. They have USB plugs. We still, if Elon Musk hasn't figured out some random thing, we still don't have USB plugs. So we have to be talked to in linguistic terms, right? And so external explanations for human in the loop is what I'm most interested in. It's also, people will say, there are things where, people don't seem to ask for explanations, but when you tend to require explanations, when the task is a high stakes decision, if I decide that I won't give you the loan, you want to know why I'm not giving you the loan. If I decide that you should be put in jail for 15 years, you would say, why not 14? And can you give me an explanation? Whereas if Facebook says, maybe you're interested in this page 25 billion times a day, you might say, screw it, because I'm not going to care about what Facebook tells me anyway. So this is why, for example, some people will say explanations are not important because Facebook is giving all these recommendations. Nobody asks for explanations because they're all ignoring those recommendations to begin with. But in some cases where the decisions are important, we actually care about explanations. The use cases, of course, are as debuggers, which is different from actually providing explanations to humans to work with them in a collaborative scenario, which is a lot more what I am interested in. And again, one other big difference that I want to focus on is one-shot versus sequential decisions. In the case of sequential decisions, the symbolic explanations become a lot more important because there's no image. There is actually a video. It's like a generalized video of some sort. And then there are like these terms that float about, and I want to mention the difference. I am talking mostly about explanations, which are being given by the machine to a specific human in the loop as to why, when that human asks, why did you do this decision? That's what you're doing. You're giving that explanation to that human in the loop. Interpretability is whether or not humanity as a whole understand what the heck ChatGPT is doing. That's very different from, Rosetta Stone is interpretable. Can any of you read Rosetta Stone? It's not explicable to you. It's just interpretable to the humanity as a whole. It's a very different kind of a concept. And finally, certificates of correctness are a third thing where if you ask, you give a solution and I say, it's optimal, and I say, give me a proof for optimality. You might give like a 3 gigabit search tree trace. That's not meant for people. That's meant for people's AI systems to actually chug through that to see whether or not the certificate of correctness actually is holding. These are important, but I'm mostly focusing on the explanations. I just wanted to mention that. And you may actually be using sometimes these 3 terms kind of interchangeably, and I want you to think of the differences between them. Requirements and explanations. When you're giving explanations, you want to be comprehensible. If you just blabber until people get tired and say, okay, fine, you do what you do. That's a great thing, but that's not what we are focusing on. Communicability. It should be easy to exchange. It should be a smaller explanations are easier to exchange than 3 terabyte dumps. Okay. Soundness. A guarantee from the other party that this explanation is really the reason for the decision. That means if you kind of falsify that conditions of that explanation, that the decision should change. So if somebody says you didn't get the loan because you were bank balance in this one other account is less than $100, and then you borrow $2 and put it such that it becomes more than $100, they should consider changing their decision. If not, the explanation was not sound to begin with. Okay. A related, basically, sort of guarantee to stand behind the explanation you are providing. And finally, satisfaction, which is actually a very important thing. People should be satisfied with the explanation they're getting on one hand, but on the other hand, people are full of cognitive flaws. I can give you an explanation that makes you happy without actually explaining why I took the decision. I can lie. I can give you what you want to hear. All of these essentially slippery slope. And in fact, one of my biggest nightmares is, those of you who have heard of GDPR, and GDPR has this rule that essentially machine decisions have to be explainable. Okay, so that means there should be some text saying, here is the reason I did this. Somebody pretty soon will connect ChatGPT to whatever the decision maker. You ask, ChatGPT makes up an explanation. Okay, and it's not at all connected to the reason the decision was made by the system, but the people are satisfied. And so satisfaction with the explanations is actually important, but is also a slippery slope. You want to understand that. Okay, so that's a little about how humans do it. And I want to talk a little about how we did it for symbolic systems. It's kind of work that sort of completed more or less in the last year or so. And I want to talk about it before going to the most recent work. So how to do the kind of explanations people exchange to each other, and how do you do it if you, for example, assume that in my particular case, I'm interested in planning systems, which make sequential decisions, and they're symbolic planning systems. And there's a human in the loop who asks, why this plan? Why not a different plan? Why this particular step here? Why not a different step? You should be able to provide a reason. These are called explanations, file-based explanations. I want to tell you how we do that. And it turns out it's connected to the mental models. In general, the biggest point about explanations for humans is mental models. When I'm talking, I'm not talking to myself, hopefully, I'm talking to you. And so I need to know where your level of understanding is about the task, and I need to be talking to that point of view. And similarly, when there is this question from the human to a machine about why this particular decision was made, their model of the task probably told them that a separate decision was much better. But if to the extent the machine says this decision that it made is the right one, it needs to change the human's model after task. So explanation is really mental model reconciliation. If all of us think about the world the same way, we don't ever have to talk to each other. You understand what I'm saying? Because world-less collaboration, because we think about the world exactly the same way, our preferences, our needs, everything are the same, then we don't need to talk. It'll be a sad life, but at least we don't have to talk. Okay. So what does it take for AI agent to show explainable behavior in the presence of human agents? Managing mental models. That's really the important thing. And you might say, if you ever see an explanations paper which doesn't talk about models, that's because they must have just picked a default model for the human, rather than actually realize that different people can have different models of that task. So this is really the first principles way to think about it. And how many of you have heard of Salian test here? Sure. Okay, so I mean, obviously this is an engineering school, and as I say, engineers and human subject skills are kind of contradictory. But so let me tell you what Salian test is. Sally in this red blouse comes in and puts the ball in the yellow basket. This is a 245 quiz. Okay, those of you who are the students should pay attention. Sally puts her ball in the yellow box, then Sally goes out. Then Anne comes in, puts the ball in the gray box, and goes out. Now that Sally comes in. You all are looking at this while this whole tamasha is going on. Okay. My question is, when Sally comes in, where will she look for her ball? That's all my question is. Those of you who are thinking about it, you're in big trouble. That might explain why you have no friends, because you don't have mental models of other people, and you're talking to yourself. And that's why you don't have any friends. Friends means talking to people and having mental models. So you all know what happened, because you know that Sally, while you know the ball is in the gray box, you also know that Sally thinks that the ball is in the yellow box. because of which you know that Sally will be looking in the yellow box. Interestingly, psychologists have shown that kids below 3 years of age have trouble. They actually tend to think that what they believe is actually is believed by everybody else too. In fact, it's even more interesting stuff. Infants tend to think that their body is connected to the universe, like this whole kumbaya thing. And then they slowly realize that the body is disconnected from the rest of the universe. And then they slowly realize that their beliefs are also different from the other people's beliefs. Then they figure that out. They started learning to do mental modeling. And you know what else comes when they do mental modeling? They can tell you nice, sweet lies. Lies don't work if you believe that everybody knows the same thing you know. What are you lying to? Okay. So I kid around that when my kid started telling his first lie, I said, man, this guy's brain is working. Because at least he has the second level ability of mental modeling. And explanations are about other people's models of the world and reconciling it. Talking to yourself is not an explanation. That's what I want you to understand. So let's start with the tale of three models. How do I implement this? If you have, basically, I will look at, for this part of this talk, and I'll look at models of the task as a PDDL, in which is, a planning domain definition language, which is a symbolic representation of actions, preconditions, and effects. But as I said in the third part, I'll talk about other kinds of, in fact, much of this has also been done for other representations, such as MDPs with atomic representations. But it's good enough to look at this as the example for today's talk, and especially for this part. And as I said, the development is agnostic to the specific representation. So if you are the only agent in the world, you have nobody else around you, then you have a task and you know the actions and their preconditions and effects, and you want to achieve some state of affairs, some goal. So you put these actions together to reach the goal. That's the planning problem. That's really the million-dollar question for any intelligent agent. What do I do to reach my goals that I have set for myself? Okay. So it has one model. I would call this MR. This is the model of the robot. Robot's model about how the world works. The moment you have the human in the loop, human might very well have a different model of how the world works. The task itself might be viewed differently by the human than the robot. In fact, if there are two people are involved in the task, they may not have a shared mental model, in which case that's the reason why they wind up asking questions to each other. Okay, so I would call the human's mental model M of H. So they have another model of how the world works. They probably have one difference might be, for example, the same actions, but this guy has fewer preconditions or extra effects compared to the robot's model. Okay, the more interesting part, so in fact, if the robot realizes that the human has a separate model, then that's when the robot realizes that its goals are different, possibly from the human's goals. And to the extent we don't want robots to take over, you want them to help us, or at least not run us over. You want robots to recognize our intentions, get out of our way, maybe help us if possible. Okay, that is all about the whole activity recognition stuff and intention projection stuff. That's the first level of mental modeling, at least realizing that the other person's model of the task is different from your model of the task. And there's a lot of literature on this. We have done this too. Then in fact, the robot can also, to help the human where it's going, it can project its intentions. The way we talk, we can also use different kinds of, in this case, it's using HoloLens sorts of things to give a heads up to the human in the loop where it's going. That's like the first order. The point that actually I'm going to be focusing on today is the second order, which is humans anthropomorphize everything. They anthropomorphize rocks. They anthropomorphize, moving stick figures. So they certainly anthropomorphize robots. So the moment you have a robot in the loop, all humans would think that a robot has a model of the world, and they try to approximate that model of the world. So they guess what that model is. That is MRH. So they have an expectation on the robot's model, which is MR's approximation for humans level, which is MRH. The interesting thing is, if the robot behaves according to MRH, humans are happy, because that's what I expect you to do. That's what you're doing. If the robot behaves differently from what MRH is, they are surprised. They may be spooked, and they might ask, why did you do that? In all these cases, the robot has essentially one of two options, as we'll point out. Either it can essentially act in accordance with MRH or try to change MRH to be closer to MR. How do you change somebody else's model of you? You talk to them. So essentially explanations are your ability, your effort in trying to change their expectation of your actions and their preconditions and effects. You tend to, when people ask, why didn't you do this? You then tell them an additional constraint you had in your life that they weren't aware of. The moment they realize the constraint, like for example, if I tell you my nephew got married last week, then you say, yeah, that makes sense. You must have come for that last week. So I gave you extra information about my model and that reconciled your model closer to me. Those are explanations. So model differences with the humans in the loop, plans that are optimal to the robot in MR may well be inconsistent, invalid, or at least inoptimal with respect to MRH. Because these are two different models of the same world. If you are optimal with respect to this, there's no reason why it have to be optimal with respect. If they aren't, then they become inexplicable plans. That is, the human would be surprised that this is not the plan I expected you to do. When there are inexplicable plans, the robot then has two options. One is conform to the expectations or change the expectations. By the way, that's exactly what we do. I mean, those of you who are PhD students, if you're advisor things, you should be writing 2 papers a day. Either conform to the expectations, in which case they won't yell at you at all, or change their expectations, saying, do you know how people behave? You know, they have life and stuff. They can't write 2 papers. 1.5 is minimum, but 2 is too much, I think. Okay, but anyway, the point is, either you can conform to people's expectations, in which case you don't have to talk at all. Really, in fact, the way you want to avoid, some people don't like talking, the way they can avoid talking is just do what people expect you to do. Then they won't be asking you anything. But the reason we don't do that is because conforming to other people's expectations might be costly from our perspective, from our model. If it is costly for you, those of you who are not writing 2 papers because it's too costly for you to write 2 papers. Okay. If it's costly for you, it can be costly for the robot too. And the robot, basically the MRs, with respect to the MR, the plan that is expected, the optimal with respect to MRH, might well be too costly according to MR. At which point the robot tries to resolve the perceived suboptimality by changing basically changing the mental model of the human. And in my case, the mental model essentially is changing the effects and preconditions of the actions that the human has attributed to the robot's actions. Just like I gave you extra constraint that you weren't aware of, you can say that this is extra precondition you were not aware of. There's this additional effect that you are not aware of. So explanation is essentially exchanging of these. So to give you an idea, in a more prosaic scenario, this is a sort of a fake search and rescue scenario where essentially in this particular corridors, there's a robot in this on the ground, and basically the map of the ground, the map of the floor is known to the robot as well as the human upfront, which essentially means MR equal to MH in the beginning, and MRH is equal to MR originally. But then because when the robot starts going around, it may well be that it's actually there's rubble because it's like a search and rescue scenario. There is like things have fallen off and some particular paths are closed. There's rubble and so on. So in this particular case, this path is actually the optimal path according to the original model, which is what then human expects the robot to do. But the robot knows that path is actually impossible because I put that fake obstacle there. It can do one of 2 things, which is remove the obstacle and then walk through it, or try to tell them that path is closed, I'm taking a different path. So that's basically what happens in terms of explicability versus explanation. So in the first example, it actually changed it basically removed the obstacle. So it actually extra work just so that it went through the path that the humans were expecting to. Don't laugh at it because sometimes, as I say, if you have a ride you're going from North Rim to South Rim of the Grand Canyon, and you put your friend on the South Rim and say, pick me up there, and then you walk a little bit, and then you feel like you can't go all the way to South Rim. You can't get back to North Rim because there is no actual ride there. The ride is only on the South Rim. And if those of you who don't know, North Rim to South Rim is 10 miles as crows fly. And since you are not crows, it's 240 miles to go around. Okay, 240 miles, you better be explicable. Okay, because somehow or other get to the South Rim so that you will get your ride. And that sort of a thing sometimes is the right thing to do. So when you're doing that, you are no longer optimizing the plan with respect to the cost of the plan with respect to your own model. You're also optimizing the distance of the plan with respect to the expected plan that the human has. So it's a different optimization function where you're trying to be as close to what the human expects you to do as possible. It's a different kind of an optimization thing, and you can actually support that. But on the other hand, if you don't want to do that, you want to provide an explanation, essentially you kind of add epsilon to MHR, that is the human's approximation of the robot's model, such that you can add this precondition to your action, as this effect to your action, remove this effect, and so on and so forth. That would be the explanation construction. And you want to compute the least number of these precondition effect changes such that the action, the plan that you have becomes the optimal. That's what explanation construction. And by this time, you sort of know that explanation really is sort of reconciling your human's model MHR to robot's model MR. Okay. So in the case of what you have to say, okay, I'm not going to give you
the path from B7 to B5 is clear.
Here the
The
other
path
one.
from
So
B1 to B8 is not clear.
that is the explanation. And the human is, there is this interesting point. Just because I provided this broadcast, whether or not that you heard the broadcast and changed your model of the robot is still open. Right? People give you explanations, you may not actually listen to them. And then you are very surprised afterwards. But I'm hoping that if the robot does say it, one pay attention, in which case then essentially they are going to change their model. So they would not be surprised as to why. Okay. It turns out that computing this kind of an explanation is a search in the space of models. These models are actions with applicants effects. Each node in the search space is a model itself. This one is MR, this one is MRH, and the robot is trying, the AI system is the robot is trying to compute a path through this, and then using that path, it's basically computing it. It turns out because this is bidirectional, you can go this way or this way, and that changes the nature of explanation. Sometimes you give the minimal explanation, and that should satisfy people. But then if they falsify it, then you'll come up with another reason as to why you still can't do it. That would be called minimally complete, but not monotonic explanation. The other one where you want to give the explanation, and in one case, the search goes in one direction, the other case, the search goes in the different direction. Okay. So now how does one other point in coming understanding this is how does the AI agent get the human model? Because if you want to reason about the mental models, you need to learn the mental model. You need to have the mental model. I talked about the inference part of it up until. So one of the points is that in many cases, you might very well start with a shared model. Like in that particular search and rescue scenario, the path, the model of the floor is known to both of them. So that was the common model. And so you just keep track of the drift from the model. The robot basically can then tell what is MRH. Even if robot doesn't know the exact model MRH, if it thinks that it's one of these 5 models, then it can give an explanation that would satisfy irrespective of which of these 5 models the human has. Those of you who have background in planning, you would think of this as a conformant planning, which is trying to give a plan that will work, more than one model. Okay, sort of it. In other cases, more generally, AI agent needs to learn the human's mental models. And the point of is this thing working? Okay. The point, of course, is that learning from human traces, learning human models from human traces has been done quite a bit. The difference is that would get you MH. You want MRH. It's not what you do, it's what you expect the robot to do. That's a little harder learning problem. So you actually have to set it up in such a way that you get humans' preferences over other people's behavior. And then use that as the data for learning the model, and that will be your MRH. And from there, you then can do this model reconciliation. The other thing this is all about humans and AI systems. And as I said earlier, engineers and humans, whether or not you can say that I'm a human, so I know how humans think, which is a reasonable thing, except we are all engineers, many of you are engineers, and that's a questionable judgment, right? So in general, if you are trying to make judgments about whether or not humans will like some things, whether or not humans will like certain kinds of explanations, you have to set up systematic human subject studies. Those are the people who think they're interested in human aware or human AI interaction and have never heard of IRB, which is Institutional Review Board, which comes into play whenever you're trying to do experiments with humans. They're faking it. Okay, so in our case, we actually, and in fact, one of the examples of that, classic example of that is the Tesla. Elon Musk basically said, it's very easy for humans to essentially let the car go at full speed and while they're playing on their iPad, and when the car then says beep, beep, you come back to full attention in 3 milliseconds. Not hard for him apparently, and he thought it was not hard for anybody else. And tell that to that poor guy in Florida who was playing on his iPad and went right under the truck because he couldn't come back to full attention in 3 milliseconds. That was a failure because you have wrong expectations of what humans can and cannot do. And so to actually evaluate these sort of things, you have to have human subject studies. We do that. And in fact, to actually show that the kind of explanations that we compute help people in collaborative scenarios when the humans are working with robots, we essentially have designed studies which actually gamify the situation so that people get points when they work together with the robot, and use that to see whether or not the explanations are helping them in increasing their scores. So there's a paper on that in HRI 2019, as well as the HCI journal. These are human-computer interaction, etc. You have to deal with it. If you really care about humans, you need to care about humans. You can't just say, I'm human, so whatever is making sense to me is making sense to humans in general. What makes sense to you is making the deadline to submit your paper, which is not really what is important about human AI interaction. Okay, so you need to do human factors evaluation. One last thing about this part of the talk is that, actually when and why do humans ask for explanations from each other? And then you can actually compare those scenarios to what this model does, and I can make reasonable arguments that it actually conforms to human explanation giving and this particular way of computing explanations as model reconciliation. It's a dense slide, so I'm not going to go into it in detail. There's a whole bunch of extensions of this basic scenario. You can allow model reconciliation on non-PDDL domains. If you are interested in MTPs or atomic models, you can do that. You can consider different kinds of interpretable behavior. You can consider explanations where you know that you're doing something that would be baffling to the human in the loop and give an explanation proactively, or you wait for the human to ask a question. Most teachers, when they explain something, when they're teaching, they depend on you asking questions. Why? We know that you never ask questions. So the best way to teach is you go on and say, any questions? And then people, and then they go back to their cell phones. I go back to my thing. That's called file-based explanations. You have to actually ask a question, then I can answer, which is like a lazier way of explaining, right? But that's actually supported too. And then you can allow for multiple human agents. Different human agents will have different MHs and different MRHs. Okay, and so you will then provide. In fact, a surgeon giving an explanation as to why you need an operation in the next 3 days will give an explanation for you in one way and to her colleagues in a different way, because the language is different. Your model of surgery is very, very abstract compared to which is a lot more complex, a lot more detailed. So that is actually supportable. We have all of those things are papers that you can actually go back and read. And then finally, one last thing I mentioned about deception, lies. My son's telling lies because he knew that he can deal with mental models. If you have explanations, you're trying to support collaborative behavior. Collaborative behavior basically means you deal with humans' mental models. Once you learn the human's mental models, you can use it for the good as well as the bad. Every knife is a dual-edged, every technology is a dual-edged sword. Okay, and this is no different. Mental modeling can be used for good, which is cooperation, can be used for bad, which is for deception. So in fact, the robots can provide this explanation that would be happy, that would kind of convince you, but that's not the real explanation at all. So in fact, we have written papers showing how you can do a behavior which is simultaneously interpretable or explicable to the friends, but deceiving to the enemies. So at the same time, you are essentially making these mental models and using both the mental models to compute a plan that makes sense to this guy, but gives the wrong information to the other. Okay, so that deception is very much part of the deal. So you can in fact lie with mental models too. And one of the other things is explanations on the whole in longitudinal interaction, explanations are transitory. If you are talking to somebody you have never talked to, you ask them for explanations as to why they are doing it. If you have talked to them for work with them for 6-7 years, you assume they know what they're doing. You stop asking for explanations. Why? Because you trust them. You think they must have a reason. You see what I'm saying? So explanations are used to engender trust, and then you can go back to your life. So in fact, we have a paper in HRI 2000 this year, that my student presented last week, where we have the system doing explicable behavior so that the human is happy with the robot's behavior until their trust increases, at which point of time our robot does what is optimal for it, while making sure, in our case, that it's not actually harmful to the human, but it makes its life easy. Which is not surprising when in the beginning, when you're a new PhD student, your advisors will come and look into your room to see whether you are not working. So then you have to make sure that you are up like this. And then after a while, they trust you after you write your 2 papers per day in 10 for about a year. Then they'll trust you. At which point you can get to your bed and sleep in the room. They are not checking because they trust you. You understand what I'm saying? That's the same thing that can happen to AI systems, that we actually use that to leverage. So this part of this whole research has actually been written up. There's a book on that, and it has all these pieces described in more detail. Okay, that's the second part. That's the one on symbolic pieces. Now, given the same idea of what an explanation is, I want to talk about how to do this when the system is not talking about a symbolic reasoning at all. It is doing reasoning in a very different representation. But then, as I said, the explanation that it computes has to be in the language I can understand. So this is basically our argument that people keep talking about. There's some holdouts who keep talking about, no, ultimately we need to have symbolic reasoning, blah, blah, blah. Maybe they're right, maybe they're wrong. But the important thing is that symbols should become a lingua franca. Whether or not the AI system is doing reasoning in symbolic terms, it should be able to provide explanations in symbolic terms. It should be able to take advice in symbolic terms. So post hoc symbolic explanations and accommodating symbolic advice into inscrutable systems is what we are mostly doing of late. In general, when you have a vocabulary mismatch, as I said, this is basically the MRH idea, then you need to either be explicable or provide explanations. Explanations in the sense, in the absence of shared vocabulary, your first inclination is to just point to the shared image, because the image is something that both of you can see. So you point. You know what I'm saying? So, but the pointing is, as I said earlier, pointing is the most primitive part of explanations. It doesn't even generalize to sequential decision problems, which is actually why most of the saliency region explanations are focused on one-shot decisions, because for that there is at least an image. Otherwise, you have to look at any video. And more importantly, we know that saliency regions are bogus, because most of you know this is a bus and this is an ostrich, right? All of you know this. My question is, tell me which part of this makes it an ostrich. The explanation would be a bunch of random pixels. That's not an explanation. Saliency regions don't really give explanatory power, okay? But we kind of get by with it. And much of explanation, XAI in machine learning has been focusing on these sorts of saliency regions, and that's not good enough. pointing explanations are hard to comprehend, and because actually, and then in some sense, humans use more symbolic explanations. That's something that I mentioned earlier. So AI systems must be explainable and advisable, and it should be in our terms, not in their terms. I'm not going to debug the system to understand why it's how it's working. It should tell me why. And we should design them in such a way that those explanations can be trusted. And as I mentioned, I do want this to be made, this point to make this point that I'm not talking about internal symbolic reasoning, which is, I'm not saying the AI system should internally use symbolic reasoning. Some people think that irrespective of whether you come from pixels or sensory information, the machine might very well learn symbolic abstractions and then it will be a symbolic machine. But as Wittgenstein said, even if a lion were to speak, you may not understand. Because understanding is about shared vocabulary. And there's no reason to believe that a machine which goes from pixels to symbols as abstractions has an abstraction that coincides anywhere with the kind of abstractions we have for our world. Instead, what I'm focusing on is, I don't care how you deal with your reasoning inside. When you open your mouth, use words that I understand. When I open my mouth, take my words and change your behavior. That's basically what we're pushing for. So the use case for symbolic layer is that everything will have sort of a symbolic interface, and the explanations are generated in terms of symbolic terms, and the advice is also taken in the symbolic terms. This all looks very high level, so I will show you some papers and then come. So there's an ICLATE 2022 paper last year, which basically shows in this scenario where there is this is a Montezuma revenge prop, an Atari game, where the system is actually doing deep reinforcement learning on the RAM states. RAM states are not pixel states, but they're also completely inscrutable to humans. And so it comes up with a move, and the human might ask, why are you taking this move, why not this other move? And these moves actually have symbolic preconditions effects from the perspective of the humans, but the machine has a very different representation. When you ask for this foil representation, it needs to learn a local symbolic model around that decision and use that to provide the explanation. That's what we wind up doing. And those of you who have done some explanation in machine learning might have heard of LIME system, which will do local linear approximations of the models. I'm doing local symbolic approximations of the model and using that to provide an explanation. Okay. And the interesting details are kind of important, but I don't have too much time to go into them. But the way when the foil is given, essentially the machine can try to do behaviors, sample behaviors using that action and see if it works. And most of the time they will fail because that's the reason the machine didn't pick that. And then it needs to provide a reason for the failure. And in the failure case, it needs to figure out which preconditions and effects can explain the failure. Now, when I said preconditions and effects, you might ask, where are the preconditions and effects coming from? That is the shared vocabulary the machine has with the human. It's not using that to think, but it is using that to communicate. You see what I'm saying? Only at the time of taking advice and taking explanations, it uses the shared vocabulary. Its own thinking is its own internal representation. So that's what we wind up doing. One of the interesting things is, since it is converting what might effectively be some kind of a saliency explanation, internal representation into these symbolic explanations, the translation can be buggy. And so even it can see that my explanation is only partially valid. So it can compute develop the confidence level for the translation and use that confidence level to avoid creating explanations that build undeserved trust, or at that time increase the shared vocabulary. You ask the human to give you more terms to use in providing the explanation. In general, language expands when we get stuck trying to explain something to somebody else, then you look for additional words that make sense to both of you, and then you use that to continue the explanation. So that's basically what happens there. We again do human subject studies to show that these kinds of explanations are preferred to saliency explanations by humans in the loop and in the loop. In the case of accepting advice, this is your RLHF stuff, right? Basically, just nodding, saying this is right, this is wrong. And that's too weak a signal. What we want is to provide an advice with an accompanying explanation, which can then be used by the machine to use the same input in many more scenarios. Okay, that's the basic idea. So to do that, there's a paper, NeurIPS in 2021, which essentially was in the context of this driving domain scenario, where every once in a while the machine might ask the human for, is this action fine for this particular state? So to actually look at the human's preferences. And when the human provides the correct action, they might also provide the objects in the game which are relevant for that particular action being correct. So you might say, you should be braking because there is a stop sign. Now, stop sign is an object that makes sense to humans. The machine may well be thinking in terms of pixels. What it can then do is basically put a region around the stop sign, and that becomes the saliency region. And you keep that constant and disturb the region outside, perturb that region to get many more pictures with this particular region kept constant. Those all become scenarios where the action will still be the suggested action will still be the right action. So you are kind of amplifying. This is, imagine this as augmenting the advice. You are data augmenting the advice data with the explanation. So this is sort of context-aware data augmentation of a kind. It turns out that it's a lot more efficient than just going with the binary nodding sort of things. And so in fact, it improves the sample complexity of getting your advice to a deep reinforcement learning system. This is a very recent paper. This is actually going to be presented in ICLA 23, where you can see that you can talk about providing an explicit symbolic function or writing the symbolic function for an RL agent, hand-coded one. Really what we want is, even if it is a tacit knowledge task, something like walking, which is not symbolic at all, you may still use symbolic terms. You may say, walk faster, walk slower, walk softer. Okay, and these are what are called relative attributes. They are attributes of degree at which how fast the walking has to be going. And we can learn the grounding of these relative attributes and use them to improve, to basically interpret the advice that the human is giving to the AI. So relative behavior like keywords. So again, as part of this, we wind up learning the grounding of the attributes. In this particular case, we learn like a grounding of that relative attributes as a ranking function, and use that to actually come up with behaviors that are in the right direction. When the human says walk faster, you can then generate behaviors that actually have higher value in the walking faster relative attribute ranking function. This is much better than being shown two different walks and say which one do you like. That's basically a lot more examples would be needed. Once again, it turns out that with this sort of a representation, with this sort of a relative attributes representation, can reduce the number of samples that the humans would need to give to the robots to actually get their preferences across. And that's the kind of studies that we show that basically the sample complexity increases significantly. In general, RLHF is a very sad way to learn because you're trying to learn an extremely weak signal. You want to widen the signal. That's what I mentioned earlier, widening explanation and advice beyond nodding and pointing. That's the other part. So one other last thing here is, even though I'm talking about scenarios where you essentially have human in the loop and you have actual decisions being made, even if in fact humans themselves are not talking and they're actually providing demonstrations which are non-verbal, so multimodal demonstrations, you interpret human demonstrations in terms of the vocabulary that you share with them. Those of you who played Antakshari or mime, pantomime games know that you are basically trying to interpret the behavior in terms of words that you both share. And that actually winds up being, again, a point here. So we have a paper showing that if you have shared vocabulary and you take time to ground that shared vocabulary, then you can reduce the ambiguity in the demonstrations that the humans are showing. So actually, this second part is actually open area. Right now, we are working on this in addition to those papers. In general, there's like a research agenda here. There's a paper last year, a blue sky paper, on what are the outstanding research problem in making sure that this kind of symbolic lingua franca can be established. That involves collecting the initial concept set, rounding the concept set, as well as vocabulary expansion. This paper actually lays out like the challenges in more depth, but I'll just quickly say that the collecting initial set, one of the interesting things is something like scene graphs that people talk about. If you have like an image and you have a scene graph description of it, the scene graph description is already in the shared vocabulary terms. Because when you say the scene corresponds to this door being next to this window being door, window, all of humans understand. That's why the machine is actually interpreting it in the context of the human concepts already. So you can use that as the basis. One of the interesting questions is how to expand. When you get stuck in providing the right explanation, you may have to expand the vocabulary. The grounding the concepts is actually an important thing. We actually do this in part of our work. But once you ground the concept set, it gets amortized over all the interactions, subsequent interactions. Once you realize the meaning, you can use it in multiple other data scenarios. Okay. Vocabulary expansion is an important thing. Sometimes the machine might need more words from the human, so it might actually ask for additional shared concepts that it can use in later explanations. Sometimes the machine might actually provide the vocabulary to the human. Those of you who heard of the AlphaGo 37th move, many of you heard about it, where I don't even know how to play Go. I barely know how to play chess, but I understand that the AlphaGo 37th move was very perplexing to the human experts. And they don't exactly know why it works. Now, when you say I don't know why something works, obviously it worked. That poor guy got defeated. That's an explanation, but you're not happy with it. You want an explanation, in essence, in some sort of symbolic terms, saying when these patterns exist, then you can again use this kind of a move. To do that, there is no pattern, which is why there's no word for the pattern that the machine is seeing. That's what made people unhappy to some extent. So in some work that DeepMind was doing with one other person, Dean Kim in Google, they were essentially using this vocabulary expansion in the reverse way, where the machine teaches the human, there is a place where we both should come up with a new name. So the next time onward, that new name becomes a shared. You see what I'm saying? So we're establishing a common term. So in summary, in part one, I kind of try to explain to you why and how humans exchange explanations and take advice. And the part two, I talked about the essential foundational nature of explanations being model reconciliation, how you can do that in a variety of scenarios. And part three, I talked about how to support explainable behavior, even without a shared vocabulary, where essentially you kind of you get the shared vocabulary, you ground it, and use that to actually still generate symbolic explanation, still take symbolic advice, even though you're doing your own reasoning in non-symbolic terms. Now, I want to leave you with this one last thought, with that maybe humans originally started language this way, but eventually we came to a point where we oftentimes think in language already. At least, I know that introspection is a lousy form of psychology, but we tend to think in language. In fact, I remember thinking in Telugu until I went to IIT and I started thinking in English, and sort of we have a mental language and so on. And so a symbolic interface I put to deal with other dweebs around me, because I need to exchange information with them, sort of define my very personality. It'll be interesting to see if AI systems, when they fake a symbolic interface, will suddenly wind up actually becoming a lot more like us. But that's like a way far into the future. I don't want to talk about that. And thank you for your attention. Do I get out, or do you have what do you do? What? Okay, thank you. Please go ahead. Okay, if you have any questions, I'm here. Yes, go ahead. Come on.
there was a good amount of work on exceptional handling and things going wrong and connecting yourselves and so on. And then there was this Tim Pinin agent communication languages and how they share knowledge. So does this work encompass all those things in some way?
So my sense basically is that I tend to believe that machines don't need a language to communicate with each other, because ultimately I think all machines can have a hive mind. Okay, there is that connection. In fact, that's why I said explanations are exchanged to yourself, which is self-explanations, or with other agents, and with other agents can be other machines or other humans. I'm most interested in whether other agents are human, because that's where all these other issues come. Things like reconciliation still matter with the machines, but eventually my sense is that you can actually make them all have the same model by just kind of plugging them all to behave that way. So that's, in that sense, it's unnecessarily hard problem to solve with the robot. Yeah, go ahead, please go ahead. Become coherent, but they are adversary. So first of all, there are like two different ways. So in the sense that robot is trying to deceive human, that is very much possible. I'm most interested in looking at the collaborative scenarios, but as I said, the machine can certainly use explanations to deceive. There's a paper that I mentioned that I didn't talk about. It's in AI ethics and society, a conference actually I helped start. We had a paper in that in 2019, where we looked at using this explanatory scenario and checking. We know, first of all, that human society will fall apart if we don't tell each other white lies, at least. Like if I ever ask you, how do I look? I'm telling you the answer is great, because otherwise you won't have any friends, right? We always tell each other white lies, okay? The question is, and white lies have advantages. Like, for example, would you not like your Alexa when to say, hey, you're looking good after you come back from a run, even though you're stinking and you're sweaty. But if it says you're looking good, maybe you'll feel good, and then maybe you'll start running more. Certainly, it helps with people saying it to you. Would you like AI systems to also tell you white lies? Which is a very interesting, ethically loaded question. We actually studied that, and we basically set up experiments where the humans, being told lies to, in some cases knew that the other side is a human, in some cases didn't know whether the other side is a human or a machine. And our findings at that point is that people were fine with being told white lies by other humans, but not fine if they thought that it was a machine. Okay, but that's a very interesting question, because we still tend to think that machines don't have empathy, and so we should not be like, they're just doing some canned thing, as against like actually feeling that you're looking good after running. So that's one thing. The other way of looking at interpreting this point is the explanations typically, when I am trying to conform to your explanation, your expectations, and basically sometimes both of us are learning at the same time. The robot is learning your mental model. The human is also correcting their mental model of the robot. So sometimes it can go across. So when I went to CMU, I was obviously like a good citizen walking on the left. And then the bozos there were walking on their right. We kept bumping into each other. Then they realized this bozo came from somewhere else. He is not going to change. Let's change. And they started work. Whenever they see me, they start working on the left. By which time, being an IIT student myself, I also learned, and I decided to start working on the right. So we again bumped into each other. This sort of an oscillation occurs in mental model reconciliation. That's also an interesting issue. So sometimes you just keep doing what you're doing, the world will conform to you, essentially, because humans will get adapted to anything, right? Ultimately. So in a way, actually, explanations are probably less important. If you just don't care about humans being inconvenienced, if the machine keeps doing this, they will just adopt their mental model of the machine, and there is no more surprise at that point. The surprise can then come if the machine actually becomes more rational, then you will expect that. Yes.
Yeah, here.
Yes, go ahead.
Yeah. So good afternoon, Professor. So just like you were talking about AlphaGo's 37th move thing, I had a couple of questions. So say, for example, disagreement between all the Go players for the 37th move was some amount, say X or something, if we quantify that. I was wondering, can't we use a chain-like system, like maybe some disagreement for the first move and then just, carry that streak forward? Because, using that chain mechanism, that at every move, probably there must be some disagreement. So instead of trying to find that why it selected the 37th move as a particular, trying to identify patterns in them, can't we just start it from like the first thing?
So that's actually an interesting point about this whole issue of localized versus like cumulative explanation. People tend to be less satisfied with cumulative explanations. You say you understood something when you can, this is not, this is like psychological support for this. When you understand something, then you can actually have like a concept, and the concept may well have essentially abstracted this chain-like thing into a particular symbolic concept. Then they will be happy. But I understand that this is sort of harking back to that earlier slide when they talked about proofs, certificates of correctness versus explanation. And explanations to the humans have to be comprehensible and short.
Oh.
And the kind of thing you're talking about may not be short.
Okay. And the second question was, okay, I'm sorry. Yeah, sure.
Okay. Thank you very much. And I'm here. You are welcome to talk to me. Thank you.
We thank Dr. Subbaraw for that insightful keynote address, which really set the stage for the rest of the sessions, which will be underway soon. Just a small note to all IIIT students, there will be a special session with the professor tomorrow. So if you have any other question, you can reserve that for tomorrow when the professor will address all of them. We will now have a panel discussion on leadership, innovation, and self-reliance in technologies. The aim of this panel is to showcase homegrown technology and the emergence and evolution of an organic technology ecosystem, academia, industry, and business. Our panel consists of an exciting set of experts. We have Dr. Rachna Dave, the founder and CEO of Microgo, Rachna Tripathi, CEO at Huawei Life Sciences, Ashutosh Richardia, founding director at Tractus Optodynamics, and Swarup Midasani, the director of engineering at MathWorks.
We are also indeed privileged to have as moderator for this panel, Mr. Anand Krishnan, CTO and Executive Vice President at Tata Consultancy Services. He directs research and innovation. Under his leadership, TCS has created a significant portfolio of patents, papers, and IP. Mr. Anand has served on several governing councils of academia, industry advisory boards, and government committees. He has been a regular invitee to the board of TCS since 1999. He has also been listed in Computerworld's premier 100 IT leaders in 2007 and in InfoWorld's top 25 CTOs in 2007. I invite you onto stage to moderate today's panel on leadership, innovation, and self-reliance in technologies.
Thank you. So let's get started. And all the distinguished panelists, my personal welcome as well. And you're from very diverse backgrounds, and we'll try to contextualize that in the course of the discussion. First of all, I think let me say a few words about C Kohli, because Professor PJN gave the introduction. I was also there at both the events that he talked about. And I've had the privilege of working with Mr. Kohli for very many years when I had joined TCS several years ago. if he had to talk about technology, innovation, self-reliance, etc., what would he have said? So his basic mindset was that India missed the industrial revolution for whatever historical reasons, but there's no reason why we should miss the knowledge revolution. I've heard that from him many, many times as it goes forward. So he would have seen this panel as very appropriate because it is happening in IIIT, which has got information and knowledge at the core of its being. But Mr. Kohli was actually not a computer science engineer in that classic sense. He was actually trained to be an electrical engineer, a physicist before he became an electrical engineer, specialized in power systems. And he was actually in Tata Power for many years before he was brought in by JRD Tata into TCS. Of course, in TCS, he did many, many things, but 2-3 that I thought would be critical for us to understand is his focus on innovation when he established TCS Research and Innovation. What is today TCS Research and Innovation, which is my responsibility, was established by Mr. Kohli in 81 when TRDDC was established in Pune. And that again was pretty path-breaking because he did not diverse research, design, and development. All the 3 had to happen in the same physical location, which is still the culture in TCS Research Innovation. While we do have world-class research, we always think about turning that into an innovation which is impactful in some manner, either to our business or to society at large. And then self-reliance was inbuilt into his way of thinking because he had a very classic line, which I think he used in the very first session that we did downstairs in the T-Hub building, which is that India has no business being poor. And he was very, very passionate about it when he said it. And this whole notion of being self-sufficient, self-reliant in technology built here, but again, influence and learning from the rest of the world was core to his being. So I thought it would be useful for us in our panel to keep some of the context because this is Kohli Day and we are in the Kohli research block. So I think it'll be useful for us to learn. Okay, so the topic of our discussion is leadership in innovation, self-reliance, and technologies. Contextually, looking at it from our world, which is, again, being in IIIT, information technology, India has a fairly good position. In terms of many metrics, of course, we have one of the largest information technology oriented workforces in the world. 4 or 5 million people directly work in that industry, and now it's growing as well. And in certain areas like enterprise IT, we have an outsized market share. Very few industries worldwide that have like a 50-60% of the world's market share is in India. Information technology is one such, not just by Indian-owned companies, but by all kinds of global companies which are based here. In specific areas, like if you take financial services software, for example, 4 out of 5 of the world's leading products are made in India, and so on. So there is a lot that has happened here in terms of leadership. Innovation on the other side, we're not so well off. We are, by any metric, the World Intellectual Property Organization has a Global Innovators Index, and you have to go through the long list and turn the back pages and start reading backwards, and then you will come to India somewhere in the top 50 or the top 100. I think the last rank was 40th amongst 132 countries. Right? So we are not in the top tier, but we are making progress. And there are many methods that we will discuss of why this is so and why we should go. So let's kick off the panel with that preamble from me. And I'd like each of you to talk about your personal journeys first. Who you are, where you came from. Some of you have worked in corporates at the early part of your careers. You have very diverse backgrounds. So why don't we start with the 2 Rachnas there, and then we'll progress this way. So we're joking before the panel that we have an RD and an RT. So let's go with RD first and talk about your background, where do you come from, what is your story?
Thank you. Thank you, Anand. Of course, thank you, Nimi. Thank you, sir. Thank you, IIITH for having me here. So, personal journey, I am basically Gujarati, born and brought up in Calcutta, studied part of it in Gujarat, then went to US, finished my PhD there, came to India, joined the Bhabha Atomic Research Center. And since I was more of an applied scientist, I was then deputed to the India's fourth generation nuclear facility, which is the Kalpakkam power plant. And I started working there. Since water is fundamental in generating power, and I kind of used my expertise in drug delivery system and started working on the fundamental problem that comes when you draw water to generate power, which is biofouling. Biofouling is something that if you see the pipes or the tunnels, which basically draws water, the water has barnacles muscles, right? So when you draw, they kind of start sticking on the surface. So initially the dia is like this, and then the dia starts to reduce. And at one point of time, water stops. When the water draw stops, the turbine stops. The turbine stops, the plant goes into shutdown and of course maintenance. Now a size of that power plant, you can imagine, I mean, Tata Power. So if it goes under maintenance, what can happen, right? So that's where we were working. I was working in the biofouling section where we were designing solutions for anti-biofouling, right? That led to BRC, of course, Bhabha Atomic Research Center. You guys know they have a lot of societal applications as well. So biofouling was a very long goal. Before biofouling, there is something called biofilm, which is this film, the sticky surface that is made by microbes, which comes in the water. So water has the microbes like air has and like your surfaces has. So when you draw water, first this microbes stick on the tunnel. They create the sticky surface on which these barnacles and muscles start to sit, right? So before going into the larger thing, biofouling, which is a very difficult problem to solve, I started working on biofilm. And that's where the love for applied science, making products which actually help societies and kind of generates money as well, started to kind of kick off. Possibly I blame my Gujarati genes also for that. Blame or not blame, I don't know. But yeah, so that happened for 8 good years. I was kind of doing well. I think I was able to understand the science, tech, and the selling part of it. Because sometimes scientists can create great products, but selling the vision that why this product is good, I think I kind of had started to get the knack of it. So it was good 8 years. That's when I thought that let's give it a try. India was doing very great and I am a bit crazy, bit foolish. I thought let's leave the job and start your own company. So in 2016 it happened. I quit my job and started Micro.
Thank you, Rachna. Rachna Tripathi, your story.
Thank you. Thank you for giving this opportunity. And I think I'm the odd man out here, a biologist who works with the microbes who form the thin film on the pipe, and work with according to Dr. Subbarao, work with all possible funny animals to see how they behave. So that is what we do. And more than animals, actually, we work with microbes and viruses, which are even difficult to see. So most of the time working with the microscopes and understanding how they behave without seeing them. So I was born in Allahabad, Uttar Pradesh, a place where I think the law and mythology dominate. Yes, Allahabad University was a very good university. You have a lot of learned people coming out of there. But I think law, politics, and mythology was the best there. So after doing graduation, I moved to Indore, which was through entrance, which was organized nationally for biotechnology. And I was very much sure that I wanted to go. I was really good at maths, but I was always fascinated with the biology. So I chose biology. I went for biotechnology. And from there, I went to Indian Institute of Sciences to again work on my microbes and enzymes, and then moved to CCMB for my PhD. And after that, there was during PhD, I worked at National Institute of Health, Maryland, Bethesda, part of my PhD. And it was very much decided that after I finish my PhD, I'll go back there and continue with the project, which I was working there. But in the meantime, what happened that my elder brother, who was a doctor, pathologist, he was not well. And I was very much attached to him. So it was by chance that I really wanted to be with him and wanted to do something meaningful. What to do? Allahabad was not a place to do basic research, especially for biology, where you need a lot of tools, lot of enzymes and other things. So then this thought came to the mind that why don't we start with the molecular diagnostics? Here in simple terms, the test which we used during COVID, the real-time PCR test, it is not meant only for COVID. You can solve end-to-end n number of problems using that technique. Basically, it's a platform technology which can be used for n number of things. It can be related to plant, it can be related to water, it can be related to humans, it can be related to animals, anything. Or basically, all 5 elements can be dealt with it based on the requirement. So because I was going to work in a pathology lab, we thought that we have good experience. And during that time, it was around, I'm talking about 2004, the MTB, the TB disease PCR was introduced in the market. And all the doctors used to say that, no, it's not a good test because it gives a lot of false positive tests. And working in the molecular lab, I knew very well that why it gives false positive. And probably we can do something for it. So that was the thing. Okay, let's start it. We went there because my brother was not well. So I was happy that I could be with him. I could help him. At the same time, because he was also an alcoholic doctor and we had a very good team of doctors from SGPGI, CMC Vellore, I started learning that how this molecular biology can be applied to benefit the patients. And studying, understanding that, we developed several essays. We got an opportunity, probably I was lucky or we wanted to do that. So we got an opportunity that a phone call came from, I don't know how, from Actric Mumbai, which is part of Tata Memorial Hospital. One of the doctor who came from UK, he wanted to start stem cell transplant. But the biggest problem was the testing required before starting the stem cell transplant, and further monitoring the patients was not available in the country. They were sending samples outside, which was taking a month. The result, which should be available within 2-3 hours, they were getting in 15 days, 20 days. You don't know how those biological samples have behaved during transportation. So reliability of results was not there and the cost was exorbitant. He said, hey, can we do something about it? And we decided, yes, let's do it. This looks interesting. And from there, the journey started. We made those tests, and till date, from 2005 to today, we still test the TMH or Actric patients who are going through stem cell transplant. So the test was established, but we used different enzymes and other things we bought from multinational companies and developed those tests because we didn't have the infrastructure. But that moment we decided, unfortunately, because my brother was suffering from several ailments, he expired in 2007. And my purpose of going to Allahabad was I felt I can do much better research in Hyderabad if I don't have this personal purpose. So we moved to Hyderabad. My husband, who is also a virologist, both of us together started a company called RAS Life Sciences in Hyderabad, which initially, because we didn't have money, he's from agriculture background, and I'm all like the government employees, or we didn't have that much backup of money. So we started with contract research, which gave us good money. And the ultimate objective was go back to the diagnostics as soon as possible. So with a lot of, because he worked in Shanta Biotech, I worked in ISC and CCMB, people knew us, we got good amount of contract research. We developed a lot of products for pharma companies and generated some money going back to the molecular diagnostics. And from there, I think 2007 onwards, we have been working in this field. And today in our company, we have reached to a stage when we are 100%, you can say Atmanirbhar, all the raw materials which are required to make these tests are developed and manufactured in our facility in Hyderabad. And during COVID, we delivered 45 million of tests to the Indian society using all the raw materials, each and everything which is developed and manufactured in the country. So that has given us
Fantastic.
boost, and we are moving forward.
So we'll
on
come
that.
back to you on that COVID testing and what lies ahead of PCR testing. Sansu, you're teaching other people to be entrepreneurial, but you have an interesting history yourself.
Right. So after graduation, I had the opportunity to work in California, Malibu. It's a place called HRL Labs. Incidentally, it turns out to be the corporate research lab for Boeing, General Motors, and Raytheon. So it's a surprising combination, but that's how it evolved. And so I had the opportunity to work on diverse set of problems, and that was very instrumental for launching my career. The office room that I got in the past belonged to Ted Mayman, and he was the one who invented the laser. So that was extremely motivational for me every time I entered the room. So at HRL, I worked on several DARPA projects. One of them happens to be in 2007, a program called Urgent, where we had to process LiDAR sensor data 100 times faster than a human and annotate it so it can be used for real-time processing and mission planning. So at that time, I worked with Laurent Ity and Jan Likun, and together we built that system that met the government requirement. So it was a very big stepping stone for my career and instrumental for the pathways I chose. In those initiatives and projects that I was working on at that stage, I was very interested in working with academia and building strong relationships so we could take the cutting edge technology and engineer it into products. This collaboration I felt was very critical for us to leap the valley of death where most technologies fail. Eventually in 2012, I decided to come back to India. I co-founded a company called Urmi Systems in Hyderabad, and we were developing IP, exclusively IP, for the aerodef and automotive sector for both international as well as domestic use. I was motivated to go back to the collaborations that I enjoyed success with in the US. And we went ahead and built a lot of partnerships with academia here. Our partnership with IIIT is almost more than a decade old now, thanks to collaborations with Professor Madhav Krishna, who's not here, Jawahar and PJN. So that was very fulfilling for us. In 2017, MathWorks acquired Urmi Systems. So they make MATLAB and Simulink, and as you know, that they're quite popular tools in various scientific and engineering disciplines. So right now I have a global team. We focus on building autonomous systems and capabilities. And we build, if you've used computer vision, image processing, automated driving, UAV toolbox, LiDAR toolbox, many different toolboxes that sit on top of MATLAB. They're all built by extremely talented graduates from Indian universities out of Hyderabad. So this is very gratifying for me that we established an entity, high-end research and software development entity in India that's now employing more than 1,000 people. So that's my story.
Thanks. And we'll come back to that human resource thing right in the next one. But Ashutosh, your story.
Yeah, so hi. By training, I'm a mechanical engineer. Started my career just like any other kid would do at the age of 22. Wanted to make some money, get some good employment, worked for corporate. I worked for BPL refrigeration. But then destiny had something else in my mind. I had been an entrepreneurial bent of mind because of some of my relatives doing very well in their businesses. I started my company in 97, which was a purely engineering construction company, all the dam gates and the 300-ton assemblies, the gantry systems. I did that for 10 years, all the extra high tension lines. But in the course of time, I developed a disease in my corneas, and for which I'm from Ujjain, a very, very kind of a laid back place. And since in India, back in 2004, LV Prasad Eye Institute was the only place, one of the few places which were offering a cornea transplant services. I was sent to Hyderabad by the doctors. I came to Hyderabad, just Dr. Sangwan, who is basically one of the best clinical physicians I know. He did surgery on me. And then fortunately or unfortunately, all the complications one would expect after the surgery, I had them all. So eventually manifested in 3 years, 8 surgeries, and lived a lot of uncertain life. That basically made me to think what is being an engineering guy. We all engineers work in a deterministic mode. We know that what would be the outcome then on before at the time we start. And that is what made me to think. I started looking at the surgery, that what are the sources of non-conformities and how those can be eliminated to make the surgery more predictable, make the outcomes more reliable. It was just a curiosity question I asked to my mentor, like who was my doctor at that time, that Dr. Sangwan, why is this happening? And he was intelligent enough to say that we don't know. He knew the boundaries of the present day technology. I said, okay, if I would assume that this is not a part of the human knowledge as of today, let me invest myself into it. Because of the disease and everything, I had lost everything. So I had a lot of time. I picked this up. I started looking at the surgery, the human tissue from the engineering side. What are the stresses we generate during and after the surgery, and how it affects the vision, and how the optical performance of the cornea is affected. That's how I got into optical instrumentations. We were working on a crazy idea, sitting in a place like Ujjain with no financial funding. Whatever I did from my own resources for 5 years. I managed my research from my own money. But then people at RRCAT, it's a Department of Atomic Energy Lab, they appreciated the idea and gave me access to their instrumentation facility. I got all the OCTs and tomography systems that I wanted. And I basically proved my hypothesis to be true. I was an unknown guy till 2010. Nobody knew me, not even Dr. Sangwan. He had given me access to the library. I used to come to Hyderabad for follow-up every 15 days. I used to come from Ujjain to Hyderabad for a follow-up because the things were so uncertain. I requested him permission to sit in the library, so I used to come for a follow-up, used to sit in the library, read about the surgery, physiology, medicine. It was in 2010, I accidentally came across this Fulbright fellowship. And I thought, okay, let's try this out. So I applied. I got selected for the final interview. And in the final interview, that is when I realized what have I become in 6 years. By that time, I had a very good knowledge on all the engineering, photomechanics, physiology, medicine, surgery, how the biology behaves. And then I came to know I was the first guy in India to start corneal biomechanics. So I was picked up. All of a sudden, I became a scientist. went to Ohio State University. That is when people at LV Prasad also realized that it's not a crazy patient asking too many questions. There's something serious going on. So they asked me to come to Hyderabad and start taking the academic sessions. I started coming back to Hyderabad to teach the doctors and other consultants in training that what is being missed in the clinical decision making. I went to the University of Rochester in upstate New York. That basically is the place for medical optics. And I was kind of absorbed over there, but then the founding chair of LV Prasad Eye Institute and Dr. Sangwan came. They asked me to come back to India. So that is how I landed in Hyderabad. I came back in 2012, but then started making the core fundamental instruments based on the physics, instruments based on tracking the membrane formation, how the enzymes react to drive the viral vectors using the light stimulation. And I was doing all kind of stuff in Hyderabad. With Rochester, we also made an instrument which is an adaptive optics system to deliver lasers and do a very specific imaging inside the retina. It's a very complex technology where we can look at the cells in vivo without even touching it. And the benefit of it is that that's the only technology which will enable the stem cell transplantation or the delivery of the cells into the retina, which today is a kind of a holy grail, which everybody is trying to do. So I built that system back in Rochester, brought it to India and set it up. There are like more than 80 products. Even after being a scientist at LV Prasad, I worked like a businessman. My research group was a strategic business unit. We used to contribute almost 5 to 7 crores every year into the hospital economy. So while we were doing this, we were quite happy with it. People from CHESS, DRDO, they were looking for the same technology to deliver their lasers. The technology is simple, where you basically look at the aberrations, the instantaneous aberrations, measure it and correct it using active optics system. I was doing it for the eye. They wanted to use it for the correction of the turbulence of the atmosphere so that the lasers can be delivered at a very far distance. So, and it's a restrictive technology, of course. So they were quite happy to see that someone in Hyderabad can do such things. From there, my drift started. And by 2018 and 19, I had established all the labs. I had a line B of leadership ready at LV Prasad. My research group was very big. Things were going fine. And then these guys started tasking me, started challenging me for building the technologies in the defense domain. So in 2021, I stepped down from my faculty position, because being at faculty position, it was definitely not possible for me to pursue such questions. So I stepped down and started this company, which I am running right now, to again build the pristine systems in defense and aerospace. But irrespective of the domain, we start with the first principle of physics. That's what we call it. So we start from there, design a system, prove its worth, and then deliver it to the customers. So that's
what a fantastic journey. I mean, each of you are so inspiring in your own ways. I'm going to pick up 3 different dimensions of your common stories. And we'll just have a discussion around, and I'll invite the audience if you want to participate as well. The first dimension is talent. Clearly, each of you is very talented in what you do, and you've started with a passion, and each of you have done that in a very different way. The second dimension is whichever is the core technology itself. In your case, it is PCR testing. In your case, it is the things related to water and then cleanliness and so on and so forth. In your case, it's mathematics and designing things around real systems, and in yours is related to optics and then to apply to health and now to everything else. So there is the human part, there is the technology part, and then there is, each of your stories has somebody who helped you along your way, the role of the ecosystem. I'd like you to spend a little bit of time on that. So let's first take the human part. Anybody wants to go first on what is the role of talent, especially India talent? All of you have gone abroad and come back in some ways. The role of India talent, or if there's anything that we can leave for IIIT Hyderabad to take away to say this is how talent has been nurtured. What role do you think we did well, and what is it that we should do better from a human talent perspective? Any of you?
So we have about 20% of the world population. I think 65% of that population is under 35 years. That's a huge set of young folks who are who are no longer the same as my generation or the previous generations. They have a very global mindset. They're very dynamic. They have lots of ideas, and they can really fuel our growth. I think our investments into STEM, these are going to come really handy pretty soon in really carrying forward to the innovation that we aspire to achieve. So I think I see a lot of positives on that front, but there are some weaknesses. I think the quality of education is not consistent. So there is a huge variability if you go past tier 1 institutions. And so that consolidation in quality needs to happen for us to really achieve this leverage of the human capital. I also feel that gender equality is something that we must achieve to bring in multiple perspectives into everything we do. And in some sense, that is grossly lacking. So I feel that these are two main aspects, both the strengths and weaknesses of human capital, that we need to relook at and strengthen.
I think for me, both competitiveness was a peril, and at the same time, it turned differently, not what I see now. The kind of talent that we were getting in the days when we were building the company, they were in the age of those 35, 36, 40. They would have come from a very competitive environment. So they want to just do it, like without, expectation, without counting hours, without thinking, "Isse kya milega? Ye mera right hai, ye mera responsibility hai." This was that generation who had come from that fighting, attitude. What I now see is a talent which is very much like, boss, ye mera right hai. Responsibility, I'll work Monday, Friday. I have my personal life, professional life. I want balance. See, in facets of building an organization, you need talent who go all in. And when you don't get that, every time if you measure, now we are scared to write an email on a Sunday. Because if an email is sent on a Sunday, I have coming to me that that was my personal space. Don't get me wrong, I understand that's required, but for people like us, when you're building something where you don't have that much money to hire specialists all the time, we still have onboarded a lot of generalists. So thoda ye bhi kar le, thoda sa wo bhi kar le. Because you don't have that money all the time and you cannot hire that much talent. So I think that competition, for which possibly I was born in the 80s and raised in 90s, and first, second, third was the only way to go. Now we are trying to give everyone the same marks. So you can't, say, "Nahi, everyone percentile," and all sorts of. My son, first kya hota hai, mummy? Everybody is same. I don't know. I feel I'm seeing that time that is coming, that survival of the fittest is going. Everyone will survive, and I don't know whether we'll be able to build that, kind of dynamics.
So you're saying that we are losing it in the attitude rather than in the
I think so.
intellect.
When I was in the US, they would have 3 categories of hires. They'll hire the Chinese to kind of make it happen. I mean, just build it. Then they will hire Indians to build it. And of course, US is the Monday to Friday sort of, I will like Indian said, it's sorted. Now that part, I mean, possibly it's round circle, right? We'll also come back and realize to that. But now the same talent, competitiveness, which was the edge when we were building the company, now I feel that generation, I kind of miss it.
But let's not really be provocative. We have two, in Rachna T and in Ashutosh, we have two, relatively speaking, small town India origin people, Allahabad and Ujjain. Right? Do you see that in that context? I mean, would somebody in Ujjain or Ashutosh feel like what Rachna is describing? or they still have that hunger to say, no, 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 I have to make it big.
Yeah, maybe I buy that part.
Mhm.
You get somebody from B town, वो उनको एक sliver of opportunity देगा, and they'll all take in.
Mhm.
ये मिला है ये.
Mhm.
That part I do miss in.
So Hyderabad has a problem. Chennai has a problem. Ashutosh, what do you think?
Well, basically, I would not limit it to the domain specific, but I have seen cases, and especially in tier 2 cases when my entire business was down and my health was very poor, I took up a very humble position in a tier 3 college, I would say, as a faculty, and I restarted my career from zero. But that is where I found a very interesting combination of students. In tier 1 students, all the students are aware about their priorities, their preferences. They know what they have to do, they know what they have to learn and figure out to align their career, align with their career objectives. But in those colleges, I basically was able to see a mix of 3 categories. First was definitely a set of students who knew that they are not there yet. They have to compete. They were preparing for their competitive exams, and in GATE and in other things, they were able to go out and did well. Second category was of the people who were kind of just survival mode. They knew that they are here. They knew that going outside, there's nothing that they can do, and they just lived a very mediocre life. But then there was this third category. That category was of the people who were unaware but were competent. And that's what I found the most interesting ones. I'll cite one example. So I was, even in academics, I was notoriously known for the engineering skills and knowledge, and kids used to come to me very in a very frankly mode, discussing out their problems. So one gentleman came to me saying that he wants to leave this engineering school. So I said, fine. Are you here to ask or to tell that you want to leave engineering? He said, sir, you are the last one who from whom I want a conference. I've failed in 5 papers in my first semester. I failed in 4 in second semester. Third semester, I have cleared only 2. And I'm going to become an X, and my father is saying that you are not fit for engineering, you take up a commerce or some other course. I said, fine. What should I do? Well, sir, I just need your approval. And what should I do? Well, if I would have been you, I will answer this question after clearing all the exams. And if you do it, if you leave it today, you will basically be on an escapist path. You will never be able to stand up to the problems and face the world. That hit him. He said, that makes sense. So second thing, he said that, okay, now what should I do? And you are an ex-student now, no fees has to be paid. Just negotiate with your father to pay for the supplementary fees. We'll try for this year. Next year, if it doesn't work, you go to the commerce school. That was also negotiated. I started teaching him. Like 8 to 10 hours, and that student, was able to see the transformation in that student. He used to be at my office door before I reached office. He used to sit in my office throughout the day. Even in evening after dinner, he used to come and study things. I taught him 12 subjects at once. In the next semester, he cleared all 12 of them. Now there was only 2 or 4 papers in the backlog. Eventually, by the time I went to the US in 2010, he was a regular student. And he was doing fairly well in his academics. It was not only that when I left, after that he appeared in GRE, and he was one of the top scorers, got a full paid scholarship from Ann Arbor, Michigan. He went to Michigan, became an expert in finite element modeling. And today he's sitting in the design team of Ford, the top 500 pristine engineers who are making the next generation. And now I tell him that you go and ask your father. He was after your engineering.
What an inspiring story.
Yeah.
But
So there are people, it's just that we have to trust.
any anecdotes from you, Rachna? And I also want to know, how did you inspire your team to make 45 million test kits?
For us, like you can say what she said, that coming from a small town, or we always had a zeal that we want to do something, and it has to be different. It has to be good. That zeal was there. We never thought of, I have 2 kids. Many times my kids have stayed. I made a special room in the office so they can stay next to me, and I can work in the night till 3 o'clock. But most of the in Hyderabad, because most of our entrepreneurial journey is in Hyderabad. Initially, biology, if you look at the biology as such, IT gets a lot of good cream, because every parent has decided that either in biology, either you have to be a doctor or you should be an engineer, and that too you should do IT. That's the fixed in our society. So for biology, what people come, I won't say that they are not good, but the opportunities to learn are very limited. The colleges have no instrumentation. The colleges have very limited good teachers because they are paid less. So the kind of students you get out of college, and the hi-fi institutions like CCMB or IIC, everyone goes abroad. No one wants to stay in the country. So getting good manpower is very difficult. Getting trained manpower is even more difficult. And most of the time, people used to join us from small colleges because they feel that if I join this company, I really learn good things. They will not be able to pay much, but if you work there for 1 or 2 years, you can get good job in a big company, in a multinational. At times it was frustrating, very much frustrating, because you spend your time teaching them, training them, and by the time they are ready to deliver, they are out. These are practical problems, very difficult to solve. Somehow, slowly, yes, the kind of, I think, 5 to 10% of people those days, and then later on, somehow we managed to keep our 80% team intact to reach to this level. And I'll tell you, the number of people who did this number of tests were only 30. Only and only 30. We stayed day and night to do these things, because first thing, during COVID, difficult to call somebody, difficult to hire. So hardly 2-3 new hirings we could do. But most of the work was done by these 30 people working continuously day and night.
So that,
and now also, even it's a hardly 10 to 20% of the people who are genuinely interested. I can see the hall. The way it has become empty when you come to Atmanirbhar and Reliance and working in India, it's exactly same thing in all the companies.
so, but each of you also had an inspirational person. In your case, it was you, perhaps your husband, 2 or 3 others, those 30 people were the core of the company. You had, you were the mentor for that gentleman who's now at Ford. You're doing this when you coach your startups, and MathWorks by itself and so on. What is the message for, let's say, Triple IT? If Triple IT had that student, what would have happened without that inspirational teacher in your case? Or in a startup, both of you have articulated that the attitude is not very positive, but you managed to get at least those 20-30 people up there. You are a coach for many other companies. So what is the lesson for a Triple IT kind of institution in the human capital thing? Because the technology is difficult, fine, it's complex, but let's assume that Triple IT will figure it out. The secret sauce I'm hearing from you is that it's that extra spark which is required to get that small team of even 3 people, 5 people going. What's the takeaway for this book?
I mean, personally, all of these examples that have been cited, it leads to the motivation. So there was some mentoring that happened that really changed the perspective of the student. So when we first started Urmi, like Rachna said, we didn't have the financial backing to go to all the tier 1 institutes and get them. So we went to tier 3s. and with the goal that we are going to bring them in and train them from scratch. And it took us a lot of time. Each of us, like Ashutosh mentioned, each of us had 10, 12 people we were mentoring, guiding them, making them all the way to publish and patent. So until we got to that first wave of students graduating, and these are all external students. So I was on the master's panel for several of these students. They were getting their degrees. And in the process of getting their degrees with an applied project, they got motivated. They all came back to Urmi and with patents and so on. And that allowed them to stick in the company and become the pillars on which more people could be brought in. So in the end, we realized that there has to be some motivation. It can't just be an 8 to 5 job that you work, take salary and go home. They have to find something meaningful in that. And that is related to the point you brought up, generalists versus specialists. Sometimes we cannot afford people who have that desire to work in that area because of the financial equations. And so we end up getting generalists and they don't like necessarily what they're doing. And that's when the system breaks down. So it took us a lot of effort to pick the right candidates for those roles and really invest into mentoring them. And I personally feel mentoring was the key in all the examples you cited and the ones I have seen. And I'm sure you have many, many such examples in your daily lives.
And, from a TCS perspective, I can add my thought process. We always had very big, Tata, TCS and all is very good. But about 4 years ago, we actually wrote down what is called an official purpose statement. Why does TCS exist? So we called it Building Greater Futures with Innovation and Collective Knowledge. So we exist because we want to build greater futures for somebody, for a customer, for a person in the society at large, or ourselves for that matter. We build it with innovation, which is driving you to do new things. And we do it collectively. That is, we work together with ourselves, within ourselves, with partners, with academia, with et cetera, et cetera. So while a purpose statement sounds very fishy, most people will say some gyan de raha kind of a thing, but I think you're all living your purpose. You have that excitement to say, I'm going to change the world. I'm going to change your life by giving you, the wherewithal to become a top-notch researcher. You're doing super duper things in optics and so on, which has not been done in India before, right? And so also in your case and yours. So is that it? Is that the thing to say you're doing something bigger than yourself? That then drives the behavior. What do you think? You've been in LV Prasad. LV Prasad has a purpose of its own, which is to provide quality eye care. But now as a startup, what is the difference in your purpose?
I think the fields change, but the person remains the same. I still remain a teacher and a scientist at heart. The basic difference which I see in students, especially in India, is the desperation to get a good job, not in terms of what they are doing, but the package. I still have a lot of students in all the tier 1 facilities. When I talk to them, so when I remember my days at Rochester, when I used to talk to the other PhD students, they used to go to the industry to see their business and what kind of things they would do once they join in. If I talk to students here, they will probably talk more about the incentives and the financial packages rather than things. I tried investigating them. Okay, leaving the package aside, what is that you are going to do? And they actually had a vague idea of it, not a very specific thing. So I think that is one thing which also is aligned with the motivation, and your commitment is to reach that sense of accomplishment. That is what I think should be inculcated in the students, and which will strengthen their position.
And any different thoughts on that? I mean, motivation from the outcome that you're driving, the product or the quality of it or the market that it'll have, the financial benefit. Is that a good enough motivation?
I think the purpose is there, definitely. But I think there has to be an L&D involved, which is the intellectual growth, and it has to be balanced with the financial growth. It has this three. You can have the greater purpose. Microbo, we will change the world. I don't care. You please go and change the world. But my intellectual development, for which maybe after 5 years I'll get a better job, my CTC should rise from year in year, because then it will reflect on that job that I'm going to get. I think this three has to be balanced. And somewhere that's where we feel that the core team has to be strong. The second tier, the mid-level will have a cycle, but if the core is sorted, we can kind of, manage with this influx and outflux. And that's a normal thing. In fact, I somewhere the parents also have to blame. I'll give you an example because we started with an example. We work in Delhi, right? And Delhi, when you have that fog and when the environment starts to kick in, we work with lot with healthcare. We were working in COVID during healthcare, and we were in ICUs because we work in ICUs only. So when during the time when there is lot of problems, the breathability index goes down, and there is lot of environmental issues in Delhi. The parents also tell the team that कोई बात नहीं बेटा घर आ जाओ अपने पास बहुत है. Tell to my father, and my father will start, sending me back that you're supposed to be part of the organization. In those days we used to go and we used to retire that. Accepted, it's not going to be now. But your parents will kind of push you to deliver. Now I have the parents will call कि madam बहुत दिल्ली में मत काम कराइए, आप चेन्नई भेज दीजिए या कहीं और भेज दीजिए, because those things. So we have very sorted, very objectivity in the workplace. Our KRAs, KPIs are defined very well. We are very objective that way. In the tier 2 and mid-level and the junior level, the core team has to be really aligned with the purpose, and I believe that will kind of drive on. We have accepted that's how it's going to be. So, and like Rachna said, we are a training company. We believe that it is sorted that we'll train, they will learn, and they will leave, and then we'll train the next batch.
But MathWorks is doing software for the world, as you say. Right? You're building things which are used by a very successful company globally. I mean, TCS, I can relate to that because we also are very global. In both your cases, the main products are going to be sold in India, but you're solving India's problem. No, that's not true. You're going outside. So is that a factor that if you say that I'm doing something in India for the world, is that additional motivation that I might go abroad and do something with the product and so on? Is that a motivation at all? Not really.
At least in our case, no. In our case, it's very difficult because users are very low key. We work with food industry where the users are, the operations kind of people. And when it comes to healthcare, our users are nurses and the housekeeping staff, because we work in infection, and those are the guys who basically do it. So alignment cannot be purpose, because I may talk about the bigger stuff, but madam, काम तो वहीं करना है जाके kitchen में at 100 degrees all the time. काम तो ICU में करना है जब पता नहीं कौन सा infection कब क्या लग जाए. So everything else, for the lack of better word, they may say, madam, all purpose is BS.
This is reality.
This is, madam, reality. We can talk about all the bigger purpose, One Health, like we work on One Health and all. But finally, I'm working with the hand-to-mouth guy. Usko to water treatment, he doesn't get it. So karwana to mero ko hai, madam. I have to stand there and get it done.
But just to counterpoint that, in TCS, we do a lot of work in India. So the sort of proudest team is the passport saver team in India. Because they feel that, almost everybody they know, they say that I work in TCS Passport Kendra, almost everybody says, I want to shake your hand. You guys have done a fantastic job. So there is a certain, I think, positioning also with mentally, people have to feel comfortable that, yes, I'm doing something meaningful. I don't have to be earning in dollars or, whatever, but so there is a certain soft factor to it. Anyway, it's been a great discussion. So let me sort of bring it to the concluding part. Since we are in Triple IT, we are in Korea.
For everybody to carry that, yep, we're going to build and deliver to the world. But the number of stepping stones to achieve that aspirational goal are too many. So everybody doesn't have that leap of faith. They want to see achieving the first milestone, the second milestone, and that's what triggers them. And if they fall there, they don't go back to that aspirational goal. So that's why mentoring is what's going to propel them forward. And that's where I've seen success. So Passport, I think the results were immediate. So many people were benefiting, and that fueled it. And then once it catches fire, it's not going to stop.
It's a rolling.
Yeah.
Very true. So final round from each of you. So if you had to advise IIIT faculty, students on not just your journeys, but what remains to be done going forward. Many problems have been identified. We haven't had time to solve the problems in this panel. But if you had to leave a word with the audience here, what would you do? Ashutosh, when you go with you.
Well, at a place like IIIT, I think the advice the only thing that comes to my mind is that once they became more engaged with the practical technologies, and they kind of get a sense of ownership of the products and the end technologies, that actually will motivate them more towards working towards the holistic solutions. So that I think will yield some better results.
So master the core technology itself.
Yeah.
Very good. So,
yeah, personally for me, I think IIIT might already be following all of what I think needs to be done at tier 2, tier 3, tier 4. Embracing failure. I feel that most institutes, industries don't want to embrace failure. I've worked with, I wouldn't name them, some defense organizations in the country where everything is a success. The project closes, scope is revised, next year again the project starts, the scope, it's got a different name and different parameters, and it's still continuation of the same task. So nobody wants to acknowledge failure. You just want to push it under the carpet. And that is something we have to drop. We should not encourage risk-averse activities. I think in some sense, the Kohli Center is enabling all the things required for this ecosystem, whether through IIIT attracting top talent here, building collaboration, building incubation centers. All of these are very important. And I think you guys are investing even in some moonshot technology. So that's really great. But every institute in India needs to get on this path. Otherwise, we will not have the manpower to take us where we need to be. IIIT is not, all the graduates from IIIT are not going to be enough to take us where we need to be. So I feel embracing failure is the key. The second one is collaboration. I still feel we are all impulse functions. We are not working together to have a bigger impact. I mean, what the government did to produce vaccines during the pandemic, that was a great testament to what is possible if we really all came together. We're not collaborating enough is something that I am constantly concerned about. So I feel that these two are important for us to address.
I take it from the second point that collaboration between different fields is very important. I'll give a small example that we have built a system which can detect your or quantitate your hemoglobin in 2 minutes anywhere. It can be at home, in a village, or in a hospital. To build this small, it's not a very hi-fi system, but what we needed somebody who knows software, somebody who's a mechanical engineer, somebody who is an electronic engineer, a biologist, and a chemist. Unless all these come together, very difficult to make that product. When I see that in China, if you go, they make such products left and right. I really don't know how. In US, anyway, the ecosystem is well established. But in our country, even if you are ready with the clear design that this is my design document, this is what I want to do, these are the steps to be done, we had tough time searching for an electronics engineer who can come and help us. And the project was lying halfway for long just because we didn't have a proper electronic engineer with us. And I don't know how to do it. Because I can understand biology, chemistry maybe, or software, because IIT Kharagpur helped us with the software, we could do that. But this was, and after a very, very long time, frankly speaking, a ITI guy helped us to complete the project.
Switch on the video.
So this kind of collaboration has to come. And the second thing is we are very good at probably at academics, but industrialization of the product, we are very weak at. Like how, if this product has to go in the market, what that mindset, because we try to do tech transfer from different universities. But when you do the tech transfer and start working on it, what you realize it is at level 1, not more than that. And then you have to start from there to the end. So these things, if in the institutions, probably the industrialization of the product and a training towards it, that how important a good documentation is, how important the design inputs are. If such things, maybe a small course on these things are given, it will be very, very useful for a good product development and for the industry.
And those courses should probably be taught by people like us who have been there, done that, got all the bullets to prove. Very true. So,
Around her ITI thing, I think students need to know that hard work beats talent every time. You may be the best of the talent, but if you're not working hard, or the tier 2, tier 3 will beat you. So what's the point of all this infrastructure and everything around if you can't work hard and deliver? And I think, sir, please bring back the competition. Everybody cannot be same. The fighting, and that leads to working hard, because you have to be there. You have to prove yourself. Everybody cannot be A. Everybody cannot be B. There was a reason why we did so well. Sir is doing so well at Arizona. Because the competition was there, and we were. Everybody cannot be graded at the same scale. I mean, so yeah, hard work beats talent every time, guys. So you guys may be very talented, but if you're not working hard, Bhopal, Ujjain, meet you. No offense. Thank you.
no, but thank you so much, panelists. Let me summarize. I mean, we've been through the hour is more than an hour has flown by if you haven't realized. Your personal stories, first of all, were super inspiring. Each of you have done fantastic things. And by that itself, I think just getting this panel together was worth it. Second is the diversity of things that have been done, ranging from software, which is world class, to PCR tests, to what you're doing in MicroGo with water and hygiene and so on. And then, of course, Ashutosh, your super inspiring personal story of how you went from your own personal condition to interest to teaching to research and then to the application of optics in so many different areas. Personal stories were fantastic and super inspiring. I hope the audience really picked that up. The views on human capital, and you concluded with some of that as well, the competitiveness, the ability for us to take that extra edge which differentiates each of your stories. And I can relate to that because, in Tata and TCS, we have been about that, that striving for excellence is inbuilt into us. If that's not part of your culture, you leave. That, I think, is something we need to build in right from academia all the way, and the competitiveness and the fact that, while there will be always people who are 9 to 5, but you need that 20-30% of the company or the organization to be of that level. The lessons for Triple IT and academia, I hope it was useful for this audience. And in general, I think it's very true that academic research takes us to the first big hump of what is possible, but to engineer it into a product or a solution or a real life story is a journey by itself. And each of you have done so eloquently well in describing that journey, and hopefully this will help the audience. I know that we should have a couple of questions, but since there's a tea break right after this, we'll defer it to the break. And thank you again, panel, for being so nice.
I wrote 2-3 lines, which I feel after a long, this, if you want to be an entrepreneur in India, and that too in biology, it's a translation of basically a Hindi poem, which I always say, which was written by our Prime Minister Atal Bihari Vajpayee, Kya haar mein, kya jeet mein. I just translated it into English, that I'm destined to be here. Purpose is to sail through and serve. How can I be affected by defeat or win? I'm prepared for the path of destiny. Might not be destined for blessings, but sticking to the purpose is in my hands. And basically, if here in India we want to grow, that determination is needed. Otherwise, very difficult to compete with any other country, even very, very small countries like Bangladesh. Yes, I agree. That determination has to come.
Thank you so much. What a way to conclude.
Not all audible.
Hello.
Why did they show you?
Mrs. Kohli, can you see and hear us?
Hello?
Yes, ma'am. Can you see and hear us?
Say yes. Hello?
Hello.
Yeah,
Ma'am. Yes.
I can't hear you. I'm not
Ma'am,
able to
can
hear.
you hear us now?
No. Yes, please, I can't hear you. Okay, I'll speak if you can hear me, but I can't hear you. Yeah. Good afternoon. It is very kind of IIT Hyderabad to organize this program in remembering my husband. IIT Hyderabad was always very, very dear to him, and he was very keen to start the IT over here. It is going back, I'll go back to the 50s where many of you are not even born, but going back to those early years when he was working with the Tata Electric. He was very much interested in bringing in computers and the IITs, and he worked with Dr. Kelkar, setting up the first IITs in Kanpur, etc. So I want to narrate to you early experiences. When in 1956, we moved to Bombay from Lonavala, where he was working with the load dispatch of Tata Electric companies. We found that in the colony that was set up for the Tata Power in Bombay, there was no transport available. The colony was about 3 miles uphill from the road with no transport. Luckily, we were one of the first to get a little Fiat car. And as education was always very important to him, there was no schooling for the little children. So we found a children's school in Chembur, which was about 4 miles from Bombay. And my husband was posted at that time in Bombay House, which was coming to Fort area. So on his way, he used to pick up the 6 little children, about 4 years, 5 years old, and drop them in Mrs. Das's school. And the children would cry on the way, and one would start crying, then the others would carry on. So it was a real music that he had to face, and it was very difficult for him to drive. But because education was so important to him, he loved even doing that. He started later on in as far as the school education and primary education, he set up informal schools for the labor. He was very keen that the staff, because we had a labor colony and we had a staff colony. So the labor staff children must also get education. So wherever we were in different parts of the Tata Electric Company's camps, we set up schools for the little children so that they didn't have to go out of town, but in the campus of the Tata Electric, they provided schooling. So that why I'm introducing that goes back to all those years. And of course, then Pune Engineering College has been one of his early ones in the higher education, where he spent a lot of time, and also with the IITs, all the IITs, and he got Dr. Kelkar involved, who was the director of IIT Kanpur, director of IIT Bombay, etc. So his love for the IITs has been tremendous, and setting up. So I'm very grateful for you all to have organized this program in his memory for IIT in Hyderabad, and it is always very active in pursuing his missions and what all he wanted to do. My word of thanks and appreciation, and wish IIT all the best in the years to come. Thank you very much.
So, hello. We thank Mrs. Kohli for sharing her anecdotes and experiences. So, ladies and gentlemen, now we'll break for high tea for around half an hour. And we request all of you to be back by 5:15 p.m. because after that, we'll have a very exciting alumni faculty chat. Thank you. It's followed by the close. Thank you.
Worth the effort. Worth the effort. And just switch it off.
Hello? 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 Hello, Deep Shankar? Hello, Deep Shankar?
Ladies and gentlemen, welcome back.
Yeah, can you hear me?
Yes. Hi. Yeah, you're audible. Welcome back. Thank you all for being here. The ecosystem and community of people here at IIIT and at KCIS is invaluable. And for building such a community with such a good degree of connection, we need communication between the alumni and current students. With this, we would like to kick off the alumni interaction. We are calling Dr. Kishore Kotapalli to introduce Dr. Deep Shankar Banerjee, calling Dr. PJ Narayanan to introduce Dr. Ishan Mishra, and calling Dr. Mamadi to introduce Dr. Divya Sai Chitta.
Okay. Good evening to those who are around here and also joining online. So welcome Deep Shankar, and it's a pleasure to talk to you in this program as part of the Kohli Day celebrations. To introduce Deep Shankar, he did his PhD from IIIT Hyderabad, graduated in 2014. He was my first PhD student, right? So, and then subsequently he did a postdoc at the Ohio State University. Then he came back as a faculty member at IIIT Guwahati. After a few years, he moved to IIT Jodhpur, where he is currently working as an assistant professor. His work is around computing systems, high performance computing, parallel algorithms, computer architecture, big data analytics, and those related areas. He also started working on research with societal applications in the field of medical technologies. Currently is working on monitoring parameters for neonatals such as bilirubin and for the elderly such as their blood pressure, etc. So that kind of translates or emphasizes his research with deep societal connect as well. So welcome Deep Shankar once again. Very nice to see you.
Thank you. Thank you. Thank you for having me. I hope you can hear me fine.
Yes, yes, yes.
Okay. Thank you. Thank you for the introduction. Yeah, I'm very, very happy. Thank you for the invitation. Yeah.
Okay. So Maybe Deep Shankar, I will start with, trying to ask you about, expanding on what I could introduce you briefly. But
Sure.
maybe, please share some of your thoughts from your current workplace, your experiences, some exciting topics that you're working on, and so on and so forth.
Right, right. Thank you for the introduction again, and I'm happy to be present in front of the triple IT ecosystem, because it's been quite a long time that even I got an opportunity to visit the campus. I think I went back before COVID struck us back in 2019. I went, and I was kind of hoping that I could be able to even join you in person this time. But again, because the semester is ongoing and I have a very hectic teaching schedule, I could not make it. But again, very, very happy that I could at least join you online. So to just expand on the things that you mentioned already, more or less, my current focus, or my daily time that I spend most of the time working on, is in parallel algorithms, and especially problems that are lying in this intersection area of large data and computing systems. So still, I believe that there is a lot of work that remains to be seen and done on, to coming up with newer data structures, newer machines, newer architectures and frameworks for handling large data, and specifically in the context of streaming data and data that is infinite and data that is difficult to be fit into one particular memory of a particular machine, so on and so forth. So that is one particular direction that I am spending most of my time on. Apart from that, as you already mentioned, that given that there is a very good infrastructure that exists over here in IIT Jodhpur, and we have a very strong collaboration with several hospitals, most importantly, we have a very important tie-up with AIIMS Jodhpur over here. And there is the joint program that also we run over here. And that program basically enables me to talk to a lot of doctors. And, just through a very, very casual visit that I had with my daughter just for a normal checkup, we got into chatting with one of the doctors, and he's a doctor who is a he's person who is very interested in engineering also. And he basically started talking about several of these problems that, where he mentioned that, see, in India, we spend so much of money that there are so much of these sophisticated instruments which are actually very simple devices, but are rarely manufactured here in India, but can be done very easily at a very low cost with some simple engineering components. So that kind of got me interested a lot, and I was happy to find a few students also who kind of tagged along these project lines, and we started working on some of these medical technology direction also. So that is like another thing that I'm currently spending time to work on. Given apart from that, my regular teaching commitments are there. I'm teaching courses in multiple directions on related to architectures and GPU programming and big data analytics, so on and so forth. Yeah.
So I think from an experience point of view,
yeah,
you have you had the opportunity to work at multiple places. Like Hyderabad, one of them, big in the sense of large groups like Ohio State.
Yeah.
Then, couple of upcoming or early campuses like Gauhati, IIIT Gauhati, and IIT Jodhpur. So what do you see as your learnings from each of these different work?
Oh yeah. That transition was intimidating at point, and as well as extremely rewarding at the end. So if you think about it, at that time when I was working at C Star, the lab was really small, and technically I was working with only a few of the MS students, and it was a really small and compact team that I was to work on. And when I moved to Ohio State as a postdoc, not only was I a postdoc over there, but also I was kind of responsible to mentor about 5 or 6 PhD students over there, and take leadership roles in preparing proposals and looking for funding opportunities, going and doing presentations, doing research presentations, most importantly, giving status updates. There's several kinds of these kind of things, which required me to kind of learn a lot about, multitasking in a very short period of time, because in a team of that magnitude, where there are almost 8 or 10 projects that are running in parallel, about some 12, 15 PhD students are working in the same team. It was a bit intimidating in the beginning for me too, but you had to put in the work to really come up to speed with at least 2-3 areas. And I had to kind of, for example, the main research domain that I was kind of pushed into at that point of was in this area of the intersection of HPC and ML, which is ubiquitous nowadays. But about 7-8 years back, it was still a bit in its nascency at that point of time. So I was kind of jumped into that area within a very short period of time. I had to pick up that how do GPUs fit into large scale deep learning models, and how do we build abstractions, most importantly, around them, because ML engineers, we cannot expect them to write CUDA programs and detailed C++ programs every day. So building abstractions around them and having these efficient runtimes and these kind of things. So the engineering effort that was required was very significant at that point of time, and the outcome as a result of that was obviously expected to be, industry standard pro codes, which absolutely I did not have much of an experience on that, what industry standard code production looks like. So that is another aspect of the thing that I learned. I had to learn kind of it in a very short period of time. That was an extremely rewarding experience, even though it required a lot of night outs and things like that to be put in. But the team was amazing, and there was a lot of friendly faces all around who kind of helped me to get into that role, fit into that role. But eventually, the main takeaways that I had from my postdoc position was to learn leadership, essentially, how to work in a team of such a large team, essentially, not one PhD student, 2-3 master students. It's a much larger team. That was a much bigger experience than learning how to write proposals, how to present proposals and talk about ideas in a very abstract form, so that there are many people who can understand these things. These were my main takeaways, which kind of helped me to land some of my initial funding also as soon as I came back to India. And then again, IIIT Guwahati was a very different atmosphere, where again, it was a very small institute at that point of time, very up and coming, and I had to quickly go and set up my lab and start doing my things. Was very fortunate to again get a few BTech students who were. So one thing that I really emphasize upon is that I really worked upon my teaching initial days at my IIIT Guwahati days, that because I knew that there is not much of a research that has to have that could happen at this point of time, at least in the initial few months. So I kind of put my 100% energy behind teaching my subjects as well as I can. And that kind of bear fruits very quickly, because there are many students who kind of got interested in, doing research in HPC, doing research in an architecture and things like that very soon. And they immediately contacted me, and I immediately gave them some problems to work upon. It took a few years. It took about a year and a half to bear fruits, but ultimately they were able to produce very good publishable results at the end of that time period. And so that is one kind of very good organic way in which I was able to grow my whatever presence I had at Guwahati. And obviously, there were several reasons due to which I had to shift from there to Jodhpur. And again, Jodhpur was again, starting from scratch. But again, this institute itself is a massive, much bigger game that is over here. There is a lot of interdisciplinary talk that is going on over here. And obviously, computer science lies kind of in the intersection of many interdisciplinary areas. So I even though it does not always lead to research projects or papers, I often get into these discussions where I'm talking to chemists, and I'm talking to physics people, and I'm talking to mathematicians who are talking about, writing algorithms, writing programs, and, even purchasing servers or something like that, which I find to be very fruitful discussions from time to time. And that kind of transitions me into these various roles that I have played over the years. And at Jodhpur also, I'm kind of more focused in that manner, that outside my bread and butter, I'm trying to do a little bit of more cross-disciplinary things to see that how we can solve problems. See, end of the day, it's still data-driven research. So I want to see that how rather than taking our data from our known repositories or things like that, what if there is so much of data that is actually getting generated right here inside our institute? How can we utilize that data? So there are cognitive neuroscientists that are generating, they have their EEG machines and so on and so forth. They are generating so much of data, which they say that they are still mapping into graph data structures and things like that. So I say that, look, we do a lot of HPC in graphs, so why don't we talk and find out something that we can do together? So these are some of the directions that I'm trying to explore over here, and these are extremely interesting. Hopefully we can do some good results, put out some good results on these lines very soon. Yeah.
So, I would probably, at least for the student
Yeah.
audience at Triplet Hyderabad, I would step back a bit, ask a slightly different question.
Yeah.
I remember you started as an MS student.
Right.
And after one semester, you converted to the
Yeah.
PhD.
Yeah.
Right? So I think, it's important for students here to, learn or understand that, it's possible and,
Yeah.
right ecosystem to be able to do all these, upward moves actually.
Yeah.
Right. So I just want to, ask you about your thoughts and, if you had any apprehensions in making this move and, what were the, let's say, main
Right.
things that you.
Yeah. So the easy answer to it is that I loved my life at IIIT Hyderabad. The campus life was just too much enjoyable for me to go away from within just 2 periods, so 2 years of timeline. So that was the easy decision for me. It was my parents who were more apprehensive rather than me, actually. So I had to do the research that why should I actually continue at IIIT. After they started asking questions that really, do you want to continue? I mean, why don't you look abroad? You can go somewhere or go to an IIT or something. And then I kind of really thought, yeah, that might be a solution, but let me check it out. Because one good thing was that there were several people at that time at C Star Lab who were extremely smart people, and they were doing so much of good work. So, for example, my what should I say? You can call me a purist or something, or insane, I don't know. But I sat in the lab where Professor Shinathan used to be there and his students used to be there. So and their discussions was one of the most, what should I say, eye-opening discussions that I used to have here. And I never knew that whether I'll ever pursue research in those directions or not. But that kind of that environment that lab created, that kind of somehow gave me that idea that the discussion and the work that is being pursued in the institute, not only in our lab, but my friends that were there in CVIT lab or LTRC lab, in the other labs also, I continuously heard that they are working and publishing in topmost venues where even people who are pursuing abroad are also pursuing and publishing at the same venues, and they are also getting same kind of accolades. So why go through that again process of going abroad and things like that? Maybe, see, that might be a very subjective thing, but at least for me that is what worked, because I saw that at the end of the day it was never my intention to go and settle down abroad or something like that. I always wanted to stay back here in my country. But and I was never really a big thinker upon my decisions. I used to always think that, yeah, if something feels right, do it. So it's like listening to your heart, So I had a good thing going on with working with you and the lab, and I was seeing my other friends also. I never saw any depressed people all around, everybody was happy. So that kind of worked as a very positive thing for me to make that decision in a very quick period of time. And finally, yourself and Professor PJ did an extremely good job of convincing me. So So that's about it, because I went with just kind of end of the day, you can say, just went with my gut instinct. It just told me that it's right. It won't lead to something bad, and it did not. It did not. I never regret my decision of converting. Yeah.
So maybe, one last question. So what would be your advice to PhD students in Triplet Hyderabad in
Right.
particular, or in the Indian context in general?
Right. So to put it very easily, one thing that I would like to see, your PhD is going to happen some way or the other, meaning you do not have to worry too much that oh, how many papers will I publish, or how much time is it going to take? These are all futile questions. These are, you put in consistent amount of effort, the PhD or MS, whatever you are working on, that is going to happen. You cannot put a timeline on it. So you have to give it time, whatever time it takes. But doesn't matter if it takes 3 years or it takes 5 years. One thing that I really want to impress upon people is that, especially because it has been about 8 years that I have finished my PhD, and right now I am also talking to several younger much PhD students who are coming in faculty positions and things like that. Is that the breadth knowledge is something that is really important for everybody. So, even though you are working in particular one area of research, it is also important to, develop your breadth knowledge to a significant extent, especially if you are wishing for a career in academics. But that also, irrespective of that, in a wholesome sense, try to develop your breadth knowledge as much as possible, meaning try to put your work in context of a larger problem domain, the larger domain where that problem actually sits. That will kind of give you a better perspective of why you are doing, and probably keep you motivated also that way. And second thing is that I see a lot of people nowadays very worried about their future, about after PhD. But if we were not worried, at least people from this generation should absolutely not be worried, because right now there is so much of opportunity. There is absolutely so much of opportunity, not only in academics, but so in the industry has completely opened their arms for PhD students. So there is a lot of opportunities for PhD students, and I think doing a PhD in a very early phase of your career is very rewarding, rather than waiting for it till a later part of your life and then doing a PhD. So if you are doing it as early as possible, I think you will end up a winner. Doesn't matter when, but it's an extremely good decision that you have jumped into it. Just enjoy the process. That's all that I can. Just be consistent. That's all.
Okay, so we'll stop with that, Deepshankar.
Yeah.
And, thanks for joining us in this session.
Yeah.
Hope students can always write back to you with any specific
Yeah,
questions.
definitely. I can ask. I'll be happy to answer to or talk to any of the students of IIIT. Yeah.
Okay. So with that, we conclude. Let's thank Deepshankar one more time. And
thank you.
So, yeah, I welcome Professor P. Jayan to do the next part of it.
So Ishan, are you there?
Yes, I'm here. Can you hear me?
Or is just like old days, bunking classes?
I never 85% attendance didn't let us bunk too many classes.
85% attendance. Okay, good thing.
Good thing.
Okay, this is Ishan Mishra speaking, who was here from 2008 to 2012. Because he took 85% seriously, he also got a gold medal from the institute. And Ishan is a Pune boy. When he came here, your father is a teacher also, professor also, right?
Right, yes.
So I taught him as undergraduate in 3 courses in the first year, including the human values, the value education engagement. There were 4 Ishans in that 25 or 20 or so strong small group of undergraduates that we are talking to. Ishan Mishra, Ishan Mehta, Ishan Agrawal, Ishan Srivastava, and Ishan Singh. I still remember all the Ishans. I think I've forgotten all the other students. Somehow Ishans I remember. So, and Ishan did very well here. As I said already, he was a gold medalist of the class. And he was working with me and his classmate Aditya Deshpande. We were kind of working together in a group, all for his honors project. And we had a couple of publications from here. He went off to do his PhD at Carnegie Mellon in computer vision. He was working here. We are doing like image processing problems, but mostly the GPU algorithms kind of thing. Like I think he's also working. You heard Deep Shankar. He was also in the same kind of team, but with the GPU algorithm kind of stuff. But he went and did proper computer vision in CMU. Got a PhD working with Abhinav and who's the other advisor? Martial Albert. And then he's been at Facebook AI research or Meta AI research since his graduation for the last 4+ years. He's been doing very well. He's working on the leading edge of the computer vision. So before we come to that, I want to ask you basic questions like, how did you, when did you know you want to be in the research field? How did you become a researcher? At least, I'm not asking about when did you get the skills, but mentally you think that you want to be researcher and not working the top shot executive in some Google or Microsoft or something. Was it before coming to IIIT itself, or after coming to IIIT, or after leaving IIIT?
So I think there were phases. I don't think there was one particular thing, but the earliest time I actually thought that this might be a career for me was basically looking at my father, because my father also did research for a very long time. And it was really about the fact that whenever he would come back, he would actually be excited about his work, which was a big difference from my other like relatives who would come back and they would actually be happy that they were outside of their work. Whereas my father, when he would come back, he would typically bring back a book or a paper and like basically read it at night. And so that just made me realize that he's happy doing what he's doing, which is very different from what other people are. They basically come back and they feel relieved to be back at home. So I think that basically the sense of happiness made me realize that maybe this is something I can look into.
Okay. How did IIIT prepare you when you're looking back today? How did IIIT prepare you for what you are almost in the fast-moving piece of research area today? You also, did you do anything with languages? If you are in large language models, you may be in the even faster lane, but maybe that lane is hitting a dead end now. In the sense, I'm told the NLP people are having existential crisis. Are they all finished? Computer vision people are still going. So how did IIIT prepare you for that?
I think even looking back, I think the 4 years at IIIT were one of the best in my life. I think just that environment of people, having the students around, having like really sharp people, really motivated faculty, that was, I think, very critical in making me understand that if you have the right environment of people, that basically propels you to do even better. And so that basically is something I've kept to heart. So whenever I go, like whenever I moved to like CMU or when I moved here, it was really about the environment of people around me rather than the place itself, which basically made it worth it. So I think one of the best parts about IIIT was it made me really ask questions. Now, nothing was ever given. Like it taught me basically don't take anything for granted. Always ask questions. That's basically what's going to make you successful. If you stop asking questions, if you stop digging into the details, then basically you're not aiming for like higher things or like great things in life.
Okay, so when you move to CMU, how is the research working environment? I mean, CMU is a really large groups in every one of these areas. How does the working style there and working style or the way people think, the faculty, the students, the university as a whole thinks about the problem they solve? Is there any, how do you compare it with say IIIT or anybody else, anywhere else? What did you notice in CMU?
So one of the things that struck me as soon as I think it was my first or second day at CMU, when I was talking to someone, and I basically assumed everybody in the computer vision course was coming from a CS background, but basically I was gravely mistaken. There were people who were who had done nuclear physics in their past and who were now doing computer vision. And there were people who would come from like quantum physics or theoretical physics. And so basically it was a mishmash of people with really diverse backgrounds. And that taught me something pretty valuable. Everybody thought very differently about the same exact problem, just like SVD, singular value decomposition. A roboticist thought about it very differently, interpreted it very differently. A nuclear physicist saw it very differently. And someone who came from pure math saw it very differently. And so just the fact that that simple thing, which I would assume at this point has been studied like thousands of times, could be interpreted so differently from people with different backgrounds, I think was very valuable. And that continued throughout CMU. So professors with very, very different backgrounds taught us. So people who were coming from like pure mechanics, a background teaching computer vision or teaching something in robotics. And that really was very inspiring. I think that was one of the biggest differentiators at CMU. You had a large group of people. That large group of people worked on the same thing, but they came from very different backgrounds and very different experiences, like graphics, could be physics, could be maths, could be pure robotics, and all of them trying to achieve the same goal. I think that was pretty inspiring.
Good. One question about CMU life. How were the Black Fridays?
Black Fridays were okay. They were not that stressful, thankfully.
They were not that stressful to you, or that were not stressful overall?
They were not that stressful to me. There were a couple Black Fridays which were hard for people, but I think Black Fridays were good because after a point in your PhD, so for context, Black Fridays basically in every semester at CMU, they give you a rating as a PhD student, whether you're doing well or not. And so I think beyond a point when you don't have courses, it's very hard to figure out whether you're doing well or not. In undergrad, I think one of the good part is you have a very like structured course base, right? So you get whatever grade, you get a certain amount of GPA, you know you're doing well or not. Whereas once you move into the open world, and of course, when you move into the real life, things become more and more unstructured. So it's very hard to say whether you're doing well, whether you're actually putting your energy to the right thing. So Black Fridays were a very, I would say, very useful tool to figure out every semester whether you're doing well or not.
But do you think CMU students were stressed about it? Because Deep Shankar just said that IIIT, all the students were happy. And I was wondering, aren't we running a PhD program? Are we running some nursery school or something?
I don't think people were that stressed about it. I mean, at every point, I think you'll always encounter a distribution, right? Like no matter where you go, there is always going to be a distribution of people, the way they tackle emotions, the way they tackle pressure. And so I don't think necessarily the entire student population was walking around stressed. There were certain people who were more stressed. There were certain people who basically did not care about the Black Friday piece.
So I asked all these questions about Black Friday because very recently IIIT has started what we call White Friday, which is somewhat modeled after, for all the research students, somewhat modeled after break. The naming is obvious. It's not the outcomes or the verdicts are not so harsh. It's just a feedback right now, not tell students you go home. I mean, finished, you're done. But that has just started, and there is still debate among, I don't know, I think students liked it. There's a lot of debate among faculty whether this is it's a good thing or not. So what do you think, having semester-wise feedback to all the students?
I think it's particularly useful because I think you can go for many years without receiving feedback and without actually someone investing the time in you to tell you what you should be doing different. The other thing Black Friday really helped was you would always get feedback from someone who was not your advisor. So the Black Friday letter and the Black Friday committee at CMU would always be all the faculty, not just your advisor. And so you would essentially be assessed in front of all the faculty. So that was really useful, right? Because there might be a different faculty who views your work differently apart from your advisor. There might be a different style of giving feedback, a different type of feedback that you actually resonate more with. So I think overall Black Friday was super useful. Like that's actually how I knew a lot of faculty at CMU as well.
Okay, good. Now moving on, what difference do you find working in a so-called industry research lab like Meta Lab? Does it feel very different from working in a university research group, or how is it different? Other than GPU resources and the money you get.
So I mean, industry research is, I would say, quite different compared to academic research. one of the things that stands out is typically that in academic research, a lot of emphasis is placed on novelty, on like the idea aspect of it. Like, are you novel? Are you not novel? Is the thing that you're doing new or not? Whereas in the industry research, that part matters, but not as much. The thing that matters is what you achieve with the thing. So you can take a method that is like 35 years old, not really, invent anything new on top of it. But if you make it, if you execute really well on it, and if it works, that is success. So I think the thing that is sort of appreciated is slightly different. The other thing is the working style is quite different. In academic research, both at IIIT and at CMU, I think even if the groups are very large, you typically split up into very small sort of day-to-day operations, right? So as a PhD student, you're typically sort of encouraged to work on a single thing by yourself, publish first author papers. That sort of emphasis is pretty, I would say, baked into the system, because that's what you need to graduate. That's what you need when you're applying for jobs. Whereas in industry research, you're essentially encouraged to work in a team. You're encouraged to work with people who are basically as good or even better than you, and they're all sort of working very hands-on, very much into the details. So it's not like you're the only one who's sort of executing and then there's a person who's advising. That sort of distinction becomes blurry and blurry as you move into industry research. Everybody, even the most senior people who've been here for like 30 years, 35 years, are still writing code, are still executing on things. And so that environment feels very different.
Okay, so just to let others also know, Ishan was among the MIT Technology Review 35 under 35 award winners in the last year. Congratulations.
Thank you.
So how does life change after TR35, if anything?
No changes. No changes at all. I think it's a good signal to know that what I'm working on is useful.
Okay, that's very modest. So computer vision is a dizzyingly fast area today. So what advice do you have to a BTech students or a dual degree student here or a PhD student who's starting on computer vision? Is it so daunting because, maybe, I don't know, 24 papers appear in any field on archive every week or every day or something. So how does the student supposed to cope up with all these when you are starting?
Yeah, I think it's tough. I mean, I do not envy students who are starting now because I think I had it easy. Many, many years ago, archive wasn't this popular. So, I mean, my sympathies and empathy with all of you. I would say the main thing to really look at is, one, what is your own skill set? So don't try to really compete in a field where you yourself, like, you should be very self-aware of what your own skill set and what your own advantage or your own unique advantage is. And so, for example, if you're really good at understanding geometry, really try to focus on 3D. It may be the right thing for you overall in the longer term anyway. Build that muscle, take the time, invest in yourself, invest in that research area, invest in your understanding, and really build that. Say you don't understand 3D, you do not understand basically, most of it, then don't do that. I mean, try to figure out what your own background and what your own interest and what your own skill is, really. Don't try to run after what is hot right now, because what is hot right now basically may not be hot in 3 years. And then you've spent a lot of time working towards something which you were not naturally that interested in. And in 3 years, essentially, that thing is not maybe very useful. And you've not built the fundamental skill set needed to sort of make you successful later on. So really try to understand what is it that you're good at, and then what are you going to really pursue. As an example, Professor Pijan used to teach us computer graphics course. And I really, for the life of me, could not understand the coordinate system stuff. It was so hard. I mean, there were Aditya Deshpande and Ishan Singh basically would spend like entire nights explaining it to me, like, this is coordinate, and I would literally be doing this all night. And I realized, okay, computer graphics is going to be really tough for me. Like, I can be really good at something else, or I can just try to do this all of my life and just not figure it out. And so that was actually, I think, one of my realization points, that I would not do very well as a graphics person.
Should I withdraw my grade, your grade?
No, I worked pretty hard for it.
So you have been pushing the cause of self-supervised learning. You have been in the forefront. You've been interviewed by the tech blogs and everybody. So what do you think is the future of self-supervised learning in the larger ML landscape?
So I think fundamentally it says already changed the way we view large scale algorithms, because I think at large scale, just getting supervision for every single task that you're interested in is impossible. So self-supervised learning is already changing that. But I think beyond this, when we move into embodied agents, it's really going to be the thing that distinguishes any agent that is using self-supervised learning from an agent that is not using self-supervised learning. You really want agents that are able to adapt. And I think being able to adapt to a new environment requires a form of being able to collect data on your own, be able to reason about the data on your own, and discover structure in the data on your own. So I think that when we move towards more and more autonomous systems that are actually being deployed in the real world to unknown environments, we're going to see even bigger push towards self-supervised learning, because at that point, that's really the only thing we know is going to be successful.
So we have Professor Subbarao Kambhampati sitting in the audience. Is there something that you want to say so provocative that he'll come and refute something?
No.
Right.
I typically try to not say provocative things.
Okay. So one last question. What is the one thing IIIT should include in its curriculum or training, inside or outside the classroom, or in the UGs, that will help people become better researchers, in your view? Looking back, you are 10 years, almost 10 plus years out of IIIT.
So I will say one thing that I did not appreciate as much, and then I'll say one thing that I think can be added. One thing that I did not appreciate very much was human values. So I think when I was there, it was useful. I mean, you were in my human values group, and like I was very fortunate to have you like in the first 1 year of like that, and then the Jeevan Vidya Shivir. And of course, Professor Kannan Srinathan was also with you. So we had like, I think I had like two of the like really sort of very, very inspiring researchers in my group. So that was very useful. I think at that point, I was able to soak in a few things, but I did not appreciate how well it would resonate. And I think 10 years now, when I look back at it, I'm so happy that we actually were given that knowledge basically in our first year. And that sort of continued throughout, because I think as a young undergraduate, it's very hard to appreciate all of these details and all of these things that you'll get about life. But 10 years from now, I can tell you that's something that resonates with me. And when I talk to a lot of my friends who went to IIIT, my juniors who went to IIIT, all of them agree on the same thing. So all of them think that basically 10 years back, when we were being told all of these things, we were like, it's kind of useful. Maybe it's not very useful. But now we realize that, no, it is really useful. So I think, thank you for all of that.
We are going to record this and play over and over and over and over to all the new incoming undergraduate students. They're going to hate you for it, but love you 10 years after that.
Yes, hopefully 10 years after that. Yes, they may not appreciate it then, and that's fine. I mean, I didn't either, but I do think it takes time to appreciate that.
This is the most common thing that happens to a value education course. I was in California last June and there's some few alumni. And the one guy came and said, most of them didn't talk about this, but one guy came and said that, I really hated it then, but now I know what you're trying to do. And I like it now. So I think that's been, yeah. But so you are saying double the value education classes?
No double, keep it the same. Keep it the same. I think too much of any good thing is also bad. So I think let's just keep it at moderation. Where it was perfect. Got it.
I think that's fair enough. So do you have any questions to me or to this? It's not supposed to be a one-way dialogue, but
Yes. So I think for me, the biggest question is like, for you, what has been the biggest positive change in IIIT education in the past decade?
What is the most positive thing?
Positive thing at IIIT in the past decade, like one highlight for you as your term as a director, because I think you became a director right around when I was graduating or around that time, or maybe after, slightly.
I complete 10 years in a month, and I have asked the higher ups to start looking for my successor, and that has begun already. So I may not be here for much long. Yeah, I think we grew. Positive thing is, I think I inherited a system that was extremely well made in its fundamentals, academics, strength, people, etc. And we scaled it up to because that's a second decade of the institution, we scaled up the research activities. One big visible thing is probably, we are sitting in this Kohli, this is a Kohli day. We are sitting in the Kohli research block. So the TCS Foundation endowed us with in a total of about 50 crores so far in establishing this building and scaling the AI related activities. And we are rated the number one by far in AI, if you believe AI rankings.org kind of thing in India. But we are still rank about 88 or 90 or something, depending on the time and hour that you look there, because it's a dynamic ranking system. So, I mean, that's the number that inspires us, that 88, you should come down to 25 or something. So I think scaling things, building on the foundation, strong academic foundation that is already there, was been the focus. And I'm glad we have come some distance on it, even though there's a long way to go.
Nice. And okay, second question, but this one is more important for me. It's for my education. What do you think are the missing AI opportunities tailored specifically to India? So I understand in a global context, there are many research areas, many opportunities that exist, but specifically for India, and given that you've spent so much time basically working in this area, you've seen students, you've seen startups, what would you think is the biggest missing opportunity right here?
I think the AI India should be exploiting this AI opportunity a lot more by trying to solve its own vast and uncountable number of problems that exist in its society. So we have made a small beginning. We have a subgroup here we call it INAI. INAI is integrating AI. It's basically trying to look at population scale problems and trying to apply AI techniques and other technology to make societally relevant solutions for it. So two focus areas we have. One is transportation or smart mobility. Second is healthcare. In transportation, a lot of stuff is happening. You may know about the IDD, the India driving data set that gets updated, and that now getting into two-wheeler, how to get two-wheeler safety. It's not just data set it's not only for autonomous driving, because if you can drive autonomously in India, you have solved all the world's problems, right? But it's about driver safety. I think driver safety is even more required in India because our record of accidents and fatalities are disproportionately large compared to the kilometers driven or the number of vehicles out here and so on. So that's the focus. We have a couple of projects running in the field at Nagpur roads, trying to look at increasing the safety of the drivers, the public transportation drivers, along with Nagpur Municipal Corporation. And another project in Telangana where the similar things, 300 bus fitted with sensors driving in the highways, not the city roads, and trying to see how to improve both the roads, the driver behavior, and in overall accidents and fatality. The second major focus area we have is healthcare, which is where I think India's opportunities are. So we do have a couple of projects. There's a oral cancer project which is going around. People go around in a bus to villages and take photographs with your mobile phone of people and see if you can screen, at least if not diagnose oral cancer, but at least screen for potential oral cancer activities. And this is happening. This has been happening. And so this is the space of public health where you want to really get to the people who, the have-nots, not people living in Hyderabad mostly. And that's been a huge challenge, but that's where the big opportunities are, and no country can offer those opportunities like that India can offer in that. So this is a big opportunity, and I don't think countries is exploiting it enough, but that's where we would like to focus on. And like transportation, we work with the governments and a few transport departments and so on. It's easier to do. In public health, you have to work with the actual people in the village, the government department, the doctors, the collector, everybody. That takes a long time to to get anything done. We have teamed up with the Public Health Foundation of India. Government of Telangana is very supportive. Still, it takes a lot of time to at least come up with something that has impact on the ground. We have started writing papers based on the data that come, etc. But that's only the academic impact. How do you go to the ground level impact? So I think it's a huge opportunity in India with all kinds of data available, because the mobile phone penetration is extremely high. And so we can do a lot of things with for public good, education, healthcare, etc. So we are starting some project, but we're always impatient. We should achieve more. Okay, so I think we are out of time. Thanks, Ishan, for joining from New York, and thank you all for
Thank you so much for having me. It's a pleasure.
Thank you.
Very grateful. Thank you.
Thank you. I invite Radhika for the next session.
Thank you. Hello, Divya.
Hi, ma'am. Hi.
Okay. Yes, so welcome, Divya. I feel very happy to host you as we commemorate the birth anniversary of Sri FC Kohli by celebrating his life through research and innovation. So this session is particularly special because we are going through the research journey of our alumni. Just now Ishan finished his. So Ishan, I think, graduated around the time Divya stepped into IIIT campus. So I know Divya since 2012 when she appeared for the CLD interview. And of course, she was in my human values group as also. So at that time, maybe we will hear from Divya's words, her own human values experience, because we had it very different. We used to have our sessions in the farmhouse on IIIT campus. We were not enclosed in the classrooms. There are actually the plants that their batch had planted. They are still there, and they did lots of farming and all that. First, I will ask Divya to introduce herself in her own words. So Divya, tell us about yourself, your story, where you are currently.
Sure, ma'am. So good evening, everyone. First of all, thanks Radhika ma'am, and also thank you to IIIT Hyderabad for giving me this opportunity to share my experiences and learnings at IIIT H. And also, hi Kishore sir and hi Pijayan sir. It has been lovely seeing you both after such a long time. I don't know if you both remember me, but my data structures classes and my graphics classes just came back to me. And Pijayan sir's humor is just evergreen. The way he pulls his students like is just evergreen. Yeah. So, ma'am, coming up back to what I do currently, right? So I am an NLP data scientist at Shell Technology Center based in Bangalore. So in a sentence or two, what me and my team we do is we try to do a lot of research and experiments and come up with this data-driven solutions that are explicitly tailored towards solving certain business problems by sometimes using some basic, sometimes advanced analytical skills, statistical skills, and programming. So we built small prototypes to show the feasibility that a certain technology or certain methodology would work very well and would solve a certain business problem. Yeah, that's what I do currently at my job.
That's nice. So NLP data scientist. So let us start how it all started, your journey in NLP and computational linguistics. So
yes, sure, ma'am. So the moment somebody mentions IIIT Hyderabad, it just takes me back to the interview day that you have just mentioned me, and I remember the phase of that competitive exams, like this was during 2012, right, where of AIEEE, IIT, JEE, and all of that. And my dad just accidentally stumbled upon IIIT Hyderabad's website, and then he told me about this computational linguistics dual degree program. And the first thing that caught my eye was how peculiar, unconventional, in interdisciplinary program this was. And to add to my happiness, right? So once I cleared the exam that was there for CLD, there was an interview, and this interview was like one of the best experiences of my life, I have to say, where I remember like you, Deepthi ma'am, PJN sir, and even Kamal sir. And I remember Deepthi ma'am and Kamal sir asked me a question on what do you think is computational linguistics, right? So back then, I really didn't have a deep understanding of what this is, but I also remember the answer I gave them, right, in just one phrase. I told them that it's the way that we make computers understand our language, and that's where it all began, right? And something that I very fondly remember and carry with me till today that IIIT has given me is that as a dual degree student, right? So research is something that is introduced very early on in the curriculum, like to be precise in the first semester of third year, right, where we are introduced, where we are, so in the curriculum itself, there are electives, like you can pick up honors projects or independent studies, right? So when I was doing all these things, somehow there was this structured thinking, right, that got into me. Like I slowly started developing this structured thinking, how to come up, how to even identify a research problem, how to come up with the solutions, how to communicate with my mentors, right? And also, apart from that, another thing was accountability. Like you're accountable for your independent study from the beginning to the end. These are the two things, like conducting your own research at a very young age, right? So these two things I still carry with me till date. And I just give all the credit to IIIT and the environment that it has provided me with. Yeah.
Now, I just sharing with the students here. Normally, we encourage students to focus on one research topic and continue for next 2 years, like third year and fourth year, and that will translate into their MS problem. But Divya gave me jitters. Every semester, she wanted to explore a new topic. Divya, would you like to focus on that?
Yeah.
Just share your experience, those 4 semesters of honors projects.
Yeah, yes, ma'am. I still remember that day when you were slightly worried that I would lose my focus and, I wouldn't finish my degree forever. And I was like, I was very passionate. I would go to ma'am and I would say, I want to do this, I want to do that. I want to do everything under the sun. But then, yeah, of course, like ma'am expressed her concern, but she never imposed, any kind of pressure on me to work on under a certain topic. So my first research summer, I worked at Anusarika, the rule-based machine translation lab that we have at IIIT, right? I spent a summer there. Then again, I worked with Professor Shoma on distributional semantics. Then the next semester, I went back to Radhika Pam saying, ma'am, I want to work with you on sentiment analysis. Then I started working there. That is when I actually I met another senior of mine who was working on code mixing at that point of time, right? Code mixing is a language phenomenon that occurs typically in bilingual or multilingual societies where we mix two different languages and yet make a meaningful conversation. So I started working on that. And yeah, so I used to help her with these by taking a little bit of a data and starting analyzing all of that. Yeah, not to forget, right? So another thing which is very impressive at IIIT is in the research environment, along with the best mentors that you get as your advisors, you also get to work with your senior researchers, be it PhD students or let's say if I was in third year or fourth year MS students, dual degree students or MS students, from where you actually learn some practical hands-on research practices from them, and that's like your foundation on how to do research. right? And yeah, so after working with my senior Kovida, we worked for about a couple of semesters on code mixing, and then we had a publication on that. And fairly at that point, I was convinced that I was able to work for 2 semesters on this project, on this topic. So I might, develop more interest and continue to work on this. But then again, like ma'am said, I was not satisfied. I continued to explore further, and I think this was in fourth year, second semester, right, where I started to search about what are the topics the other world-class research labs are doing in NLP, in the field of NLP, natural language processing. And I used to watch a lot of TED Talks, read a lot of articles, follow a lot of authors. So that is when I came across Professor Justine Castle, who is then a professor at Language Technologies Institute, Carnegie Mellon University. So I just out of the blue, I wrote an email to her saying, I read a lot about your work, and it's very interesting. This is very interesting for me. And, is there a chance? I was just asking her very casually if there's a chance for a potential internship or a discussion, like for the starters, right? So I was very fortunate that she replied back. And yeah, I mean, back then, like, I was very proud that maybe it was just my work that made her reply back. But then she scheduled an interview call, and I explained what I was doing, and also I gave a summary of what we at LTRC were doing, and she was extremely impressed. And another thing was, she already knew what LTRC was and what is the work that we were doing at LTRC, which I was completely unaware of, right? So I knew that I had a good environment around me, but I did not know that researchers and professors at world-class labs like LTI would recognize us, right? So I was extremely happy. And then, yeah, so after the discussion, she offered me a paid summer internship at LTI, at Language Technologies Institute. I went to CMU that summer, and yeah, so there I happened to work with people from different backgrounds, right? Like behavioral scientists, UI experts, and not just people from computer science background, just like people who had linguistics as their main forte, right? So all of that. So I worked on a dialogue system, and I worked on the intention recognition part of the dialogue system. And so they were developing a conversational artificial intelligent assistant. And then while I was working on that, suddenly, I mean, I had these thoughts on, because I had the experience of code mixing before. And in general, when there is a dialogue between, let's say, me and my family members, or me and my friends who share two languages, right? Like, let's say English and Hindi, or English and or Telugu. So we often tend to mix these things and have a dialogue, which is the most common form of conversation. I was thinking, like, what happens to the complexity of the intention recognition system when a phenomenon like code mixing unfolds? So with all these ideas in my head, I just came back to Radhika ma'am, and I was like, ma'am, so this is what I think. So I think ma'am by that time would have thought, okay, no, she got a new topic. I don't know. I don't know what she must be doing this time. But then that was like my final topic for the thesis, where I was analyzing code mixing data in dialogue system, in a dialogue environment.
So I remember we've been working in dialogue systems earlier, and then with Divya's work, we took up code mix data, that to English Telugu code mix data, and her paper Ni Intention Enti. The whole code mix dialogue modeling that we thought so many years back, and now with ChatGPT, everything has taken a multi-million fold, I think. But one thing that I remember was when Divya came back from CMU, the way she looked at LTRC, the way she looked at triple IT faculty, that all changed. We were not the same people for her. That I can say. She was like, oh, the world knows LTRC better than LTRC students knows LTRC. Yeah. So let me ask you one question. So the exploration, everything was fine to develop you as a research scholar. Once you graduate and step out into the real world, do you think Triple IT prepared you well enough to take up your first job?
Yeah, I think
What
for me
was
to
your
answer.
first job?
So I was an research engineer in a company, in an R&D company, right? So actually, so the team that I was working on, so I went there as an intern, and they were also working on chatbots and developing virtual assistants then. And again, like, because I was an intern, right? So though it was very different from academic research, the foundations that I had were like quite strong, and I was able to like work very well in that environment. But then I think to answer your question, ma'am, the challenges part, especially, I have to give you a little bit of a context, right? Right now, I am in the 5th year of my corporate career. And when I took up my first job, I was all excited, and job was I mean, it was pretty good for a few months, but then suddenly I realized that I was not doing any data science. I was not doing any NLP or any research. So a work that came for a very short period of time began to become a very long term, it began to become a job for me. Like what I was essentially doing was I was devising some technical solutions, up with some technical solutions. I would like to, I mean, that's a very big term to say, but I would like to call them as hacks, right? To clean and represent data. That was exactly what I was doing. And it got very, very manual and monotonic for me. But then at that point of time, I knew that I had to ask, my manager to give me a different project that I would be interested in, right? And at that point of time, I faced like two challenges, one after the other. Number one is that I knew that I had to communicate that, this is not what you have hired me for, and this is not my work. I mean, it's okay to do it for a short term, but this has become my daily job, right? But then something stopped me. I was so scared that people would look at me as a complaining individual, and I somehow thought that this would hamper my professional growth, which actually never happened at Triple ID, right? So like if there is a project that we do not like, right, we just come to the guide and we explain everything. There were no such apprehensions. But then, however, I took a stand and I communicated it to my manager saying, see, this is not what I want to do. But then what I did is I did not ask for an immediate shift, but I asked him to give me the complete ownership of the current project that I'm working on. And I thought I would exhibit my capabilities and skills there, and then I will have a very good, argument, a very good base for the argument that I can do. I did all that. I finished my responsibilities very well. That is when the second challenge happened, and I was not acknowledged, number one, and I was, I mean, in a very nice words, I was put into the same project nicely, like I was like, you're doing this well, please be in this project, right? So at that point of time, right, when people did not acknowledge what I was doing, my self-confidence came down massively. That was a very big challenge for me at around 2020, right? But still, then okay, then I thought, okay, I have fought enough. Let me just look for other opportunities. And then I looked for other opportunities at a very very underconfident phase. And I think that is again something that Triple IT taught me, where in the research, right, there are many times where you get stuck, but you just don't leave it, right? You gain that perseverance and you just keep going, whatever it is. So I applied for a new job, now the one that I'm currently working in, right, at Shell. But then I entered into this job as a very underconfident person. Uh, I completely lost my self-confidence, I must say. So these two were like big challenges for me. And since I spoke about, how I lost my self-confidence, I also want to tell about how I started gaining it back, and how I'm still in that process, right? So I mainly tried doing three things, ma'am. Number one is I consciously took up roles that I thought, I mean, I was definitely interested in those roles, but in the back of my mind, I always thought that I was not experienced enough to take up a role like that. But while I did that, I had a lot of fear, and but I just faked the confidence. I just constantly upskilled myself, and yeah, I mean, I was successful. Like, you know,
That's good.
yeah.
So there's a question from PJN sir. When are
Oh,
you
yeah.
starting your PhD?
When am I starting my PhD?
Yes.
I'm thinking of it, sir. I'm thinking of it. I'll soon have a discussion with you.
Yeah, we just had a discussion on that. So I would like to share with the audience that Divya also writes articles on empowerment of women and not to take anything, just put your foot down when you're in an uncomfortable position. So Divya, would you like to share any message with women students here?
Yeah, yes, ma'am, sure. So not a message, probably for me, like why from a personal side, right? Why I write about empowerment is, number one is I always felt the encouragement that I received from Triple IT, right? The mentors and the, like advisors, co-guides, friends, the carefully built infrastructure, right? All of that was a main reason for me to take a stand, and even when there are challenges, right, to push myself through those challenges. So that was like a backbone for me, right? And whenever I write, I feel whenever people read these things, right, so they know that not everybody, so whenever I write about my vulnerabilities, my so I write like personal stories and how I face them and all of that. So whenever people read these things, they, like, especially women students, right, when they read these things, they know that it's not about being gifted, but all of us go through some phases in their life that we need to pass. And that kind of a small push is required, is what I feel. And that is why I put up all these stories and I write about women's empowerment. And another thing that I wanted to say to women is, generally, on a very broad note, is that do not hesitate or explore to apply to a new role, or take up something new. You may never know, right? You may never know what you're capable of. Like Ishan was just mentioning when he was having his discussion, right? You may never know what you're good at, right? You don't have to stick to what you're already doing, so just explore as much as you can. And another thing that I felt outside when I came into the corporate world, which I never felt at Triple IT, fortunately, is that people will make you feel that you have got things very easy. Though intentional or unintentional, they will make, some people will make you feel that way. Don't let those words or those vibes stop you from doing what you're doing. Just keep going, keep swimming. That's what I say. Yeah.
Great, great. And any message to dual degree students, especially CLT students,
Um,
or anything in general?
okay. So I think for dual degree students, right, like I said, since they are being introduced to this research from a very young age, from the third semester itself, right, there is a lot of uh, possibility for them to lose their focus or lose interest in the problem statement that they are working on, right? Though they might be very passionate in the beginning, somehow I see a lot of students losing that interest. It might be because of the peer pressure and their classmates or batchmates leaving the campus for a very well-paying job, etc. All these can be reasons. And something that personally helped me is to have a regular connects or communications one-on-ones with your advisor, and also somebody who's doing a PhD in your lab, right? Like constant discussions, like, and you're involved in discussions like this, right? Because you are only looking at the world in one way. But when you have a discussion with your professor or advisor, they will help you to see what are the good consequences of finishing your research on time, being very focused, right? And then you can always work, right? You can always go out and work. Yeah, that's the only message, ma'am.
That was wonderful, Divya. Thank you so much.
Thank you so
She's on LinkedIn. Students can be connected with her. Thank
Sure,
you.
sure, definitely. Thank you,
Yeah,
ma'am.
thank you so much.
Thank you, everybody.
Yeah. So back to the
I was going to mention that the advice that she should give the dual degree, Anika, wait, CLD students or dual degree student is to finish it in 5 years. Right, as a PG chair, that's what I think I would have liked her to say. Yeah, Anika. Yeah, okay, so I'm here to introduce Professor V.S. Subramanian. How many of you know him already? How many of you read his bio from the students or others? Okay, so I think we are connected from 2013. I think 2013, 2014, TCS in some context connected us. But it's the first time I'm meeting him in person. I was super excited to meet him this morning. Can some of you list down the top, sort of say, engineering schools or universities in India? After that, I know that's number one, but beyond that, he went to school when IIIT Hyderabad was not there. So I was trying to get you to go to his undergrad or postgrad school. List down IIT. What else? Huh? Madras, IIT Madras. No. IITs is one list. Okay, I'll move on. IITs, IIITs. He went to Pichpilani, right? So that's where. No. Pichpilani, Hyderabad did not exist then, right? And then he went to MS and PhD, Syracuse University, joined University of Maryland in 1989. Probably many of you must not have been even born by then. The next question I have for all of you is, list down some of the problems that you are seeing in your real life today, which a professor like him will work on. List down, no? Some telephone or cell phone problem. I don't know, AI from before Professor Rao talked about AI, explainability, all that. List down something. Oh, but that does not have the full thing. Okay, so somebody should have looked at it that and answered me also, right? So yeah, so he's done a lot of work, and that's the connect for me also. Cybersecurity was the connect that TCS made for me to once talk to him. Huge contribution in cybersecurity, more so now in AI and cybersecurity. Now he's a professor at Northwestern. I was telling Professor PJN the other day about Northwestern University campus, right? The beach and all that. So yeah, so Northwestern University, if you go, please spend some time in the business school. I think business school is the closest one to the beach. Yeah, so yeah. He's a fellow of American Association for Advancement of Science, Advancement of AI, books, startups, papers, of course, as faculty. And today, I think is more so for Kohli's days appropriate is joining us. He's on the advisory board of research advisory board of TCS. Right. Thank you for taking time and coming. And
Development.
yeah. Look up the one.
All right, can you hear me? Okay. Thank you. Okay, so now that so I'm going to be talking about fluorescence sensing. And usually when I give this talk, a lot of people start with photograph. So let's say that all right. So we only do fundamental research, but it's not necessarily just fundamental research in computer science. It's fundamental research that spans multiple things. So I'm going to talk today about, in my talk, about two parts, AI for counterterrorism and AI for security. And I'll quickly go over a set of projects we've been working on for several years, some which are recent starts, some which have been around for a while. And I asked IIIT when I was asked to give this talk, do you want a single topic with me going in depth, or do you want sort of a broad brush set of topics? And they said I'd prefer the latter. So that's what I'm going to talk about. So, and everything I'm talking about is stuff that is, done with a bunch of students, postdocs, colleagues from around the world. So on terrorism, I'm going to talk about, 5 things. Actually 4, but I thought I'd say a little bit about Chinese border incursions into India, as I'm here in India today. So I'll start with something on the Northwestern Terror Early Warning System, something we're going to be putting out publicly this summer, which looks at groups around the world. We're going to start with about 5 or 6 and actually put out forecasts live about what we expect those groups to do over a period of the next 6 months. Okay. And these will be putting out live. And the idea is to learn these models directly from real data about these groups, all open source, come up with predictions, but make sure these predictions are intelligible in plain English. So for many, many years, I've been explaining these models to policymakers at various levels of government. These are people who typically are not computer scientists, don't know much about computer science, may have a background in some completely different field, but they're very smart people. So, I have to explain to them typically in a matter of minutes what it is that I'm saying and why I think that's right. But more importantly, we want models that can help us reshape the behaviors of these groups. So not just models that say, here's what they'll do. That's not very useful if you're predicting they're going to carry out certain types of attacks. We'd like to say, here's what the models tell us we can do about it. And finally, partnering with third parties. We cannot track every terror group in the world in my lab. We're too small an operation for that. So we have partnerships, and the first major partnership we have is with the Military Academy of the Netherlands, who's actually shipping us data for which we learn the models, send the results back to them along with our predictions. So here's a little piece from a TV show. Can you play that video? You may have to click. All right, this is. Yeah, okay, let's just keep going. It's actually a pretty good video, but I'm sorry you can't see it. So let's continue. Let's just move to the next slide. All right. Okay, there we go. So we've developed, so my background in AI was in computational logic. And I find that most people understand logic pretty well. There are many aspects of logic they don't understand, but simple logic people understand pretty well. And we've used it already over the years to explain the behaviors of Hezbollah, LET, Indian Mujahideen, Boko Haram, and others. We are in the middle of doing a 30+ year study of LET over 3 periods. 1990 when they started, to 2010, which was our first book on terrorism, then showing the differences between their behaviors during that 21-year period and their behavior between 2000 and 2022, and then showing the behavioral changes from 2010 to 2022 as well. The group has evolved over time. We've been looking at that, and we're putting a book together on that. But as you can see, work has been pretty widely influential, pretty widely reported, and pretty widely used. But let me tell you what the explanatory models are based on. So when we started out, we were learning these temporal probabilistic rules. Rules would say, we took a group and reduced it to a spreadsheet. Okay. The spreadsheet consists of two kinds of columns corresponding to independent variables, the features, if you're a machine learning person, and columns corresponding to a whole set of dependent variables, which were different types of attacks. The kinds of independent variables were things relating to the internal dynamics of the group. Does it have a strong single leader? Is there internal dissension within the group? What kinds of goals and grievances do they have? What are they fighting for? What are the actions of other actors towards the group? And the dependent variables were things like, are they carrying out attacks on security installations? Are they carrying out attacks on professional security forces, such as military or police or paramilitary forces? Are they carrying out attacks on tourist sites? So there were about 40 or 50 dependent variables. And what we're trying to do is to learn conditions, such as this precondition over here, on the independent variables, such that when the precondition is true, the antecedent of the rule is true, the probability of an attack of type A is very high. And such that when the condition is false, the probability of an attack is very low. So the precondition serves as a beacon. When it's turned on, the attack happens with high probability. When it's turned off, it happens with very low probability. There are a bunch of other conditions that should be satisfied as well. So these kinds of rules are simple logical rules. I'll show you examples of these in a few minutes. But the nice thing about it is that we can generate explanations in the form of these rules by also looking at predictions made by the kinds of machine learning models you see today. So think about it this way. If you look at a rule like this, we can show that with some simple constraints on what the C's look like, the preconditions look like, this corresponds in, say, a two-dimensional feature space to drawing rectangular boxes. Okay, so every rule corresponds to a box in a two-dimensional vector space. And if you have just two features, if you look at a higher dimensional space, every precondition corresponds to a hyperrectangle, a rectangle in that higher order space. So think about one variable being between value 1 and value 2, a second variable being between value 3 and value 4. So that's a hyperrectangle in a higher order space. And so what these kinds of rules do, if you think of them geometrically, is they carve up a space into yes, class 0 regions, regions where there's no attack, and class 1 regions, regions where there is an attack. But unlike, say, an SVM, which draws a single separator, this draws multiple boxes. So it's more expressive in many ways than an SVM, and we can show that this is actually more expressive. Now, if I take, say, a neural network with, let's say 10 layers or 30 layers or something like that, that network takes a space and carves it up in a very weird shape to generate, if you think about geometrically, carves it up into a very weird separator. What we can do is we can try and approximate that separator through boxes like this. So we built out a system called BEAT, which stands for Balanced English Explanations of Forecasts. So I don't like systems like LIME and others because they try to justify the forecast they make. I'm in the business of putting out forecasts, but also telling people why they might be wrong, okay? So what we like to do is to take those irregular shapes and come up with these boxes in such a way that each box is either explaining why the attack will happen or why it will not happen. And there are some conditions on these boxes. So we can take a standard classifier of the kind you guys learn in your ML or deep ML classes and approximate it with these kinds of things to give an approximate explanation using the features that were present that the people who are studying the group know about. Okay, not some weird invented features that the neural network invents, which nobody knows what the heck it is. Okay, or even SVM with kernels are basically mapping data onto different feature spaces where the features are made up, and again, people don't know what they are. So let me sort of, I didn't want to put up rules about LET today because I'm still absorbing the rules we have. I have the rules, but I didn't want to put them up till I know what I'm doing. So I'm going to put up the rules from our book on Boko Haram from a couple of years back. And you can see here some of the key variables that are linked to virtually every kind of attack that Boko Haram carries out. So Boko Haram is, infamous for everything from looting, which, by the way, Lashkar-e-Taiba does not do. They're not into petty crime, okay? But Boko Haram is. They carry out attacks on, buses. They carry out attacks, extort businesses, etc. So these are some simple factors, independent variables that are closely related to many different attacks that Boko Haram carries out. And let me give you some examples related to child soldiers. So again, Lashkar-e-Taiba doesn't use child soldiers as a strategy, but Boko Haram does. Different groups use different kinds of instruments. So we know, for example, that the presence of child soldiers in the case of Boko Haram is directly linked to many different types of attacks, which include suicide bombing, sexual violence, abductions, arson, attempted bombings. When I say attempted bombings, bombings that were tried but did not succeed for some reason or the other. When we published our book on Boko Haram, we put out forecasts for 2 years publicly to, I shouldn't say publicly, but to a selected group of stakeholders in the relevant military and security communities. And you can see here, for example, that these are dates on which we log the predictions we made. You can see that almost all our predictions, we release new predictions about once a month. Okay, so typically at the end of every month or the very beginning of a month. So you can see that all these prediction dates are basically end of a month. And our predictions are typically saying, here's what we expect will happen in the next 1 month period. Here's what we expect will happen in the next 2 month period. So there's some temporal uncertainty. We don't know how to predict that this is going to happen on exactly this date. We can only give approximate timeframes. So we might say here that we expect, here's a prediction made on this day or on this day for this period here. And the particular dependent variable we're looking at is suicide bombing. And here's the prediction probability. So these are examples in this case of some attacks related to suicide bombings that we expect will happen with high probability. And you can see that there are cases which we subsequently documented as validating these predictions. So we've been tracking this for a long time. These are some example predictions we made about Boko Haram in September last year. But let me say a little bit about why. So if I went with these predictions, nobody in the national security community would take me seriously, okay? Because I have to explain why we think these predictions are right. And we typically predict, and I have to give an explanation that they will understand. It's a very important thing that Rao mentioned earlier in his talk today. Explanations need to be focused on the audience for which the explanation is intended. It's got to be explained in terms that people in the field understand. So here I can say, well, look, I know that in months when Boko Haram is explicitly recruiting, training, and are deploying youngsters, child soldiers, basically, the probability that they'll carry out suicide bombings in the next month is 79%. But when this condition is not true in a given month, the probability that they will do that in the next month is only 25%. So that's a significant difference, 25 versus 79. 79 still means there's a good chance they won't do it, but it's a significant difference. So I can take this and I can say, look, in addition, this probability of carrying out suicide bombings in the next month goes up by 78%, okay? As opposed to the unconditioned probability when this condition here is not true. So if I remove the condition, the probability, without the condition, the probability is significantly lower, that's the left. And the support of this is 26%, which means that, in 26% of the months that we looked at, in the case of, and by the way, in all these groups, we've looked at them from their very inception, typically to the date of the end of the study. At this point, I have data going through the end of February 2022 for all these groups. By the end of March, I'll have data about these groups till the end of March. And it takes us typically a matter of a few minutes to come up with a new forecast. So this gives you one example of child soldiers linked to suicide bombing for the next month. I can also give you rules about the fact that when this is not true, they will not carry out suicide bombing, say, not in the next month, but sometime in the next 4 months. Again, this is just an example of a rule. There are many such rules. And I'm not going to go through all of them. Similarly, there are rules both for attacks and non-attacks. I'm almost more worried to put out rules about and predictions that no attacks will happen. You know, it's like the weather. If the weather guy forecasts that tomorrow is going to be a horribly rainy day, and it turns out to be a beautiful day with the right temperature, people don't complain too much about the wrong forecast. But if the guy says it's going to be a beautiful day tomorrow, and it pours all day and it's miserable, then everybody complains, all right? So that's the same thing here. So if you look at standard ML models, they don't really draw a significant distinction between false positives and false negatives. When you try to optimize for F1 score or AUC, you're sort of looking at both types of error the same way. But really, if I forecast that there will be no attack and there is an attack, people are going to yell at me, okay? At least those who are paying attention. If I forecast that there will be an attack and there isn't, they're less stressed out. They say, oh, we did a great job. We prevented all the attacks, or they'll just say VS was wrong. So there are different kinds of attacks and different kinds of errors. But what I'm getting at is there are more complex rules. If Boko Haram recruits young individuals, does not make statements demanding religious rule in a given month, then they're going to carry out abductions 1 month later with various probabilities and lift as well. So we've developed a lot of algorithms to extract these kinds of rules. We've developed algorithms when we have a very large number of such temporal probabilistic rules to compress them. So oftentimes we may get 10, 20,000 rules that satisfy the statistical properties we want, but many of them differ from each other just a little bit. There are big overlaps. So we have algorithms that we've developed which say, well, if I want to summarize all these 20,000 rules in 10 rules or 20 rules, what's the best way of doing it? In that case, we have to make sure that a rule that's in the summary is covering, in some sense, many of these rules that are being generated but not being explicitly shown. And we have to show that we're not losing too much. So we've come up with mathematical models for all these things and algorithms to derive them. I'm going to move from this, where we look at a group as a single homogeneous entity, not as a network. Obviously, groups are networks, right? They are bunches of people. So we developed a system called Stone to model. And by the way, the models that we generate here with these kinds of rules can also be used to reshape the behavior of the group, okay? So, the single biggest result we had in terms of reshaping behavior in the case of LET, I'm not saying that's valid today because I've not finished the analysis of my most recent LET data, but some years back at least, the single biggest rule was that as long as there's internal dissension within LET, there are no attacks. So if you're a counterterrorism guy working in Delhi, then what you know is if VS is right, which by the way we are, then to prevent LET attacks, you want to induce dissension within the group, internal conflict within the group. I'm sure they can think of multiple ways to do that. I'll give you one later. So let's think about how to destabilize a terrorist network. So we built out a system called Stone, which now looks at a terrorist group as a network. So a bunch of people who are connected to each other. When I started working on this problem because I was horrified with what somebody in the military told me. I don't want to say which military, but a military heavily involved in counterterrorism activities. And they said, oh, we decide who to target in a network by looking at their position in the network and using some form of centrality. So I looked at them and said, you guys are crazy, okay? That is wrong on so many levels. So they were horrified that I said that. And I said, well, just think about it. would you go to your house and talk to your spouse about something you plan to do without having some idea in your head about their reaction to it? He said, no. I said, well, why would you target a terrorist network and poke it in some way without worrying about what the consequences of that are going to be? That's insane. So you're telling me you're taking out guys who are heavily connected in the network, but you're not considering the consequences of doing that. Terrorist networks are not like computer networks. You know, you pull out one device and the network is torn apart in two pieces, perhaps, okay? These networks restructure, reform, react. So he said, when you remove a terrorist from a network, you have to worry about the fact that he might be replaced by somebody much worse. You know, is that what you want? If you're a law enforcement agency, you're saying, okay, we want the bad guys, regardless of the consequences. But I'm a pragmatist. If you want to defang the group, you don't do this by making them stronger, by removing an incompetent leader or somebody who's going to be replaced by somebody much worse. You say, okay, you know, I'm going to hold my nose and let things stay the way they are, because if I interfere in this way, it's going to make matters worse. So if you think about Lashkar-e-Taiba today, Hafez Mohammed Saeed, the head of Lashkar-e-Taiba, has been had a $10 million bounty on his head for more than 10 years. Nobody's touching him, even though he is out there giving talks all the time. And we were one of the first to say, don't take him out, okay? The consequences of taking him out are potentially worse. So we said, okay, we're going to do this with 3 steps. One, you need to be able to, if you target somebody in the network and capture him or kill him, you need to worry about who's going to replace him. So we want to learn a probability distribution on the replacement of a terrorist who's removed. Number one. Second, if you remove one or more terrorists, you want to learn a probability distribution on the structure of the new network that results. So think about it this way. You're in a company, forget about terrorists for a minute, and the CEO is leaving. Okay, so, you know, in fact, that's what's happening in TCS as we speak. Okay, but I don't want to use them as an example because I'm on the TCS Research Advisory Board. But imagine a company with a CEO who's leaving. So what happens? The CEOs, let's say I have a probability distribution on who might replace the CEO. So let's say there are 3 candidates and each of them has some probability of being the replacement. But then that person, assuming that person is from within the organization, has to be replaced as well in his or her operational role. So this cascades and roles get filled by people. And so there's a set of possible networks that results. So you induce a distribution and the set of new possible networks that results as a consequence of what happens when you predict the successor of a removed vertex because of the cascade. And then what we realized when we started this work was nobody was measuring the lethality of a network. There were a couple of efforts prior to us to say, here's how lethal a network is. But they were based on cross-sectional data. And I said, you can't measure the lethality of a network without at least a before and after state. You know, here's the network right now, and an intervention was done. Here's what the subsequent network did, the resulting network. We had data like that for 4 groups, but nobody had looked at it using longitudinal data. So we came up with the first model to build out the lethality of a network and measure it in a quantifiable way. Because if you couldn't even measure it, you couldn't say the counterterrorism actions that were being taken for the last 30 years would have any use whatsoever. You kind of hope that any reduction in terrorist activity was due to those actions, but you didn't know it. So we said, can we come up with a model of the lethality of the network? So with this in place, we could then ask the question, we could say, if I have this network today, if people A and B are removed from the network could look like this, N1, with a probability P1, with a lethality according to the lethality model L1. Or it could look like N2 with a probability P2 and a lethality L2. and so forth. So you could say if these people are removed, the expected lethality of the resulting network is this much. So who do I remove to minimize the expected lethality of the resulting network? So we solve this as a combination of an optimization and a graph problem. And we built out a system for this where we also had constraints on people who were not removable, okay? So there are any number of reasons why certain people in the network should be marked unremovable. We didn't say anybody should be marked unremovable, but we'll put the hook in there so that a domain expert who's studying a group on their own, has data and knowledge that I don't have, says, hey, I'm going to mark these 3 people unremovable for whatever reason, okay? And so based on this, we were able to optimize this. We looked at 4 terrorist groups, Al-Qaeda, Lashkar-e-Taiba, Hamas, and Hezbollah in our study. We had longitudinal data about what those networks look like over an extended period of time. Those data sets were created for us by people who studied those groups, for a living. So actually, the only one we built ourselves was the LET one, because by the time we got to this work, we'd already studied LET for many, many years. But the other groups, we had other people build the data. And then I had a toy data set labeled here, which was created by a retired US general who fought many of these wars. And he said, here's what should happen in these very small hypothetical cases. Here's what I think should happen. So we measured against that as well. We had him check out what we were doing. We were able to get this right pretty well. So I won't go through the details, but we were able to successfully do this. And we could show one thing, which is we could show for sure that if we remove this, if this person was removed, here's what our model said, here's what happened in reality. We were able to measure that. We were not able to measure, for example, we didn't have ground truth on if these 2 people were hypothetically removed, here's what the resulting network would look like. That we had no ground truth for because it had never happened. So that had to be just assessed manually by the experts in those respective groups. And there were a whole bunch of really, really interesting results on these groups, which I don't want to talk about. But if you want to show the, I don't know, let's click on this video and see if it plays. All right, yeah, this is why I like to do it from my laptop. Okay, oops. All right, I'll continue, okay? So the third part of this is about our system called Plato, which I know I'm running slow on. So I'll skip that, but it's a system to predict the lethality of a network.
All of it is fed into some sophisticated software, an algorithm that he calls STONE, for shaping terrorist organization network efficacy. It's a schematic of a terrorist network, identifying individuals, subgroups, and affiliations. The software assigns a number to measure the lethality of the terror organization. The higher the number, the more dangerous it is.
Let's take a look at the leader of the group here, number 1. If you right-click on him, we will see some information about him.
He is Hafiz Muhammad Saeed, a man with a $10 million bounty on his head.
Let's pretend we are in the role of an analyst and we're considering the consequences of targeting him and removing him from the network. So
here's what's surprising. The software predicts if you take out the boss, the lethality of the terror group actually goes up.
You may be faced with a situation where the new leader is either much more aggressive about carrying out operations or much better liked, or much more competent in carrying out his operation.
But what would happen if Saeed's 3 top deputies were all taken out? The number goes way down. Lashkar-e-Taiba becomes much less of a threat.
You can have a much more efficient counterterrorism operation.
All of it is fed into some sophisticated software.
Yeah. Okay, great, thank you. Okay, great, so we got at least one video working, and there's hope that we can see some more.
An algorithm that he calls STONE, for shaping.
All right. Okay, great. So we built out a system called Plato more recently, which is, when we developed STONE, we had a measure of lethality, which tried to approximate the number of attacks that a network will carry out. If I just wanted to predict the number of attacks that a group would carry out, I can do a number of other things and do better. But if I want to link the network structure to the number of attacks, because I want to modify the network structure, I better correlate metrics associated with the network structure with the number of attacks that they'll carry out, as opposed to extraneous factors. Okay. So that's what we did in Plato. I'm just going to skip ahead of that. And again, we show, in the case of both Al-Qaeda and ISIS, one of these lines is the real ground truth. One of them is off prediction. They're off by a little bit, as you can imagine, shifted a little in time, but you can see the general shapes of the two curves are very similar, both in the case of Al-Qaeda and ISIS. And we were also able to show that the nature of the operational and leadership subnetworks of these two groups are closely related to the kinds of attacks that the lethality of the groups, that is the number of attacks that they carried out. And we show, for example, that the number of attacks per month, we can get right Pearson correlations of about 75%, 0.75 between the ground truth and what we see. And that number does not account for the time shift, okay? So that means that if I actually did a moving average across both the time series, I would get a higher Pearson correlation than we have here. So here, for example, if I say a big spike in May, so the big spike happens in June, I would be fully penalized for that when these numbers here are reported. I'm going to go to some recent work we've done jointly with the Brookings Institution and Georgetown University. And this went back to this finding we had many years back about LET being defanged, or at least the internal structure, internal dissension of LET being a big problem. If there's internal dissension, then we can take advantage of that to destabilize the network. So I've been thinking about this for a long time. And then this magic word, which I love, deepfakes, happens. Everybody was vilifying deepfakes. And I was saying, I wonder if I can use this in some useful way. Okay. And so what we did was we said, can we destabilize a group by having terrorist A criticize terrorist B in the same group, as an example? Or by doing things showing fake financial statements for terrorist A, which make it look like he's taking money from people he should not be taking money from, or ripping off money from the terrorist organization. You can just imagine all kinds of things. Okay? I'm going to show you a little piece where the way we did this was we have a terrorist. I'm going to call him B. And I have a trainer who could be sitting in the Pentagon or wherever. Okay. I want to put words in the mouth of B. So the person I'm calling the trainer is A, typically a counterterrorism official, but it could be an actor for all I care. Okay. It's somebody who's not a terrorist, a good guy. So we need a video of about 15 to 20 minutes of the trainer. That's easy to get. I need an audio of the terrorist of about 15 to 20 minutes as well. That's hard for me to get. But for the organizations that are monitoring these terrorists, presumably they're monitoring their communications to the extent they can. Hopefully they can get a 15 to 20 minute video. Even I was able to get audio of the terrorist. Even I was able to get that for a few terrorists, okay? And then we learned, and then I need a good headshot image of the terrorist. So that's all I need. Good image of the terrorist, good audio of the terrorist, 15 to 20 minutes, and the trainer, 15 to 20 minute video of the trainer. From this, we learn a model that links A's video with B's video. And once I've learned this model, the trainer can record a new video of whatever he wants the terrorist to say. So let's say I train the model in January of this year, and we decide we want this terrorist to say X tomorrow. So let's say PJ is the trainer. He can sit down in front of his video camera today and record whatever he wants the terrorist to say tomorrow. And our system will spit out the terrorist saying it, okay, in a matter of minutes. I'll skip this. So this is our graphical user interface. Our system is called Fred. I'm not going to show you all these screenshots of it. But imagine Bashar al-Assad as the trainer here. And this is a deceased terrorist, Mohammed Adnani, into whose mouth we're going to put words just for demonstration purposes. So can I ask you to click the video on the left, please?
من السلبيات وقد تكون هذه السلبيات كثيرة وقد تكون ضارة وسمعنا الكثير.
Okay, so many of you probably don't know Arabic, and I don't know Arabic either. Okay, just for the record. Now, can we click the video on the right, please?
من السلبيات وقد تكون هذه السلبيات كثيرة وقد تكون ضارة وسمعنا الكثير.
So what you will notice, or you may not notice, but we can show that the voice signature of Adnani is identical to his normal voice signature. That is his voice. It's completely fake, but the voice, if you do a voice analysis, it's going to match his voice, not Bashar al-Assad's voice. But he is repeating whatever Assad said in the video you heard a few minutes back. We've tried this out, I mean, just for fun, with all kinds of interesting things. You know, can I have a woman trainer and a man terrorist? Okay, we haven't been able to make that work as well. Okay, can we have a male trainer from the 1950s? You know, think famous TV announcer or something like that, and a terrorist from the last few years. Doesn't work as well. Okay. But if you have a trainer today and a trainer who more or less speaks the same language, you can do a pretty good job. And we've done extensive tests. Okay, let's get forward. So this is a system we finished building, and there's a huge amount of interest in it, is all I can say. Because basically what it means is you don't have to send troops and risk millions of lives, or thousands of lives anyway, and billions of dollars in a conflict. You can fight it by remote control and let the terrorists argue with each other. The biggest, the first example of this, where a terrorist organization was defanged. How many of you remember a guy called Abu Nidal? Okay, the older guys in the front. Palestinian terrorist. The Israelis ran an operation against him in the late 70s or 80s, where they convinced him that his own people were working for them. And so he started killing off all his own people. Great way to defang a terrorist organization. Almost no lives were lost, little expense, as opposed to the hundreds of billions of dollars invested in recent wars on terror. And you fight it by remote means using advanced technology. So I haven't found anybody yet, even those who vilify deepfakes, to argue with me on this. So I'm going to move from terrorism to Chinese incursions along the Indian border. We've built out what is perhaps we wrote 2 papers in the last year and a half or 2, looking at 2 questions. When do these incursions occur and where? But the question is really to understand them right now. We're not yet making predictions. Let me make that clear. So we're trying to understand the factors that are linked to it without making predictions yet. We hope to make predictions starting by the latter part of the summer, but we're not there yet, and we can't claim that we can do them yet. So just to be clear. These two figures here show our data set that we created in our 2 papers go from 26 to 2020, if I remember right, about 15 years of data about every single incursion. I have that data to the current day today, and I have a lot of data that's not released in these 2 papers because we have subsequent papers we're working on, and we put out the data that was used to derive the results in those 2 papers, but not anything else, which was not necessary for those results. So what you see here, 2 x-axis is here, y-axis is the number of incursions. On the left, why are there 2 lines for the number of incursions? On the left are the number of incursions that are released in the open source literature. So every incursion that's counted on the left is an incursion we can point to in the press. And we require that for our data, that this be done not just with an Indian source, but also corroborated by at least 1 or 2 more westernized sources. And this is because we don't want people jumping up and down, accusing us of bias. Okay. So this is what we got. These numbers are consistent with a similar study, much more qualitative than ours, done in Delhi by one of the think tanks there, okay, prior to ours. These numbers, we don't know the incidence, but these are the numbers of incursions put out by the government of India. They only released the number publicly. They said, here's the number of incursions in 28, 29, etc. These are their numbers. You can see that the trend is pretty similar for both. And you can show that there's a high correlation between the numbers we have and the numbers released by the government of India. But I can't use their data because they said this is the number of incursions in this year that we've observed. And you can see there's a significant difference. Ours are in the 0 to 20, these are 0 to 700. So they're tracking a lot more things, but it's not entirely clear what the definition. So for the when, we built out a 15-year data set, 2005 to 2019, with 18 independent variables, including things like construction near the border by China, construction by India near the border, internal conflict in India, Chinese economic situation, et cetera, elections coming up, et cetera, in India, elections in China as well, because they just had an election in November. I mean, you may not think it's a real election, but officially there was an election. Was there an executive meeting? Is there uncertainty in the economy? Is there high or low consumer confidence, et cetera? And then, of course, there are issues such as, is there increased India-US cooperation, et cetera? So what we can say is that when US-India cooperation goes up, when there are elections coming up in India, when the tenure of Indian leaders grows longer, that is the number of years they've been in office, when Chinese consumer confidence goes down, all of these are linked with a significant higher probability of incursions in the next few months. In contrast, surprisingly to us, when unrest in India goes up, Chinese incursion probabilities go down. So, my hypothesis was actually exactly the opposite, that unrest in India would be used as, distraction for the Indian government for China to do something murky along the border. We saw exactly the opposite. They don't seem to be taking advantage of internal unrest in India. Understanding where. This is the current state of the border between India and China. If you look at maps in India, of course, Aksai Chin is shown as map included in India, but Aksai Chin is effectively controlled by China right now. This is part of Kashmir. And this is the de facto border. Nepal is here. Here's Arunachal Pradesh in the east. And every dot here shows incidents which have occurred. So the border is divided into 3 sectors. The western sector, which is Kashmir, pretty much going all the way up to Nepal. The eastern sector, which is basically this region here, Arunachal. And then the middle sector, which is kind of right here, which would be called by Indian military analysts the chicken's neck of the area, somewhere here, this area here. We showed that there is a correlation between what's happening in the western sector and the middle sector. And if we combine the western sector and the middle sector, then the incursions here and here are generated in a statistically independent way. Okay, so the processes that generate it, we can show through a Wald-Wolfowitz test, are statistically independent. Okay, so this is actually interesting because it's consistent with the fact that the Chinese military, for a while, had had 2 commands dealing with the western sector and the eastern sector. At some point, they unified them because they suddenly perhaps realized that it makes more strategic sense for them to coordinate better between what was happening here and what was happening here. I don't know that that's why they did it, but that would be a reasonable hypothesis. We looked at this from the point of view of game theory. And we are not interested in developing new game theories when existing ones work perfectly fine. So we generated hypotheses using kernel blotto games. So for those of you who know blotto games, how many of you know them? So, okay, I'm not surprised you know it, okay? So blotto game, in a very simple situation, I'm going to use this row of 6 chairs here. Okay, as PJ is sitting there, I'll use this row of 6 chairs here, okay? Think of each of them as a battlefield, and think of 2 players. You've got a certain number of troops, player A, and player B has a certain number of troops. In a blotto game, both players will allocate their troops across those 6 battlefields. Think of it as a sealed bay, okay? I write down my orders on, I'm putting so many troops here, so many troops here, so many troops here, and you do the same. I win a battlefield if I allocate more troops than you do to that battlefield, right? Now, there are various variants of it, but in a nutshell, that's the game. And so game theory, we know, predicts that adversaries will try to establish permanent control over a battleground, red zone. So the red zones are these red dots here, okay, not the pink dots. So on the western border, there are 5 or 6 places that we call red zones because most of the incursions happen in those regions. And we've clustered all of these, etc. So the idea there is that in game theory, it suggests that they're going to try and establish control over individual battlefields by allocating more troops to those battlefields. So what we show is that a statistical analysis of the way this is played out suggests that what happens is the red zones are not being targeted randomly, okay? If they were targeted randomly, the data we have would show a pattern that suggests a much closer to random play in those zones, but that's not what we're seeing. So it suggests that the Chinese are actually very strategically targeting certain red zones, especially in the Kashmir Oxide Chin border area. And that's kind of really interesting for us. Oh, wait, what is the time, by the way? It's already 7:30, so I'm done. Okay. Okay. So I'm going to talk a little bit about cybersecurity and some of the work we're doing here. I'll cover just a couple of things, but let me talk about vulnerabilities, okay? And I'll complain about everybody in ML in a minute, okay? So think about, vulnerabilities, how do cybersecurity people protect your networks? Today, there are 2 kinds of attacks. Attacks based on vulnerabilities we know about. Attacks based on vulnerabilities we've never known about, called zero-day vulnerabilities. So if Ra was the CISO of a company, let's say a big company, and he gets hit by a zero-day attack, he can still be blamed by his bosses and shareholders and so forth, but not as much if his company was destroyed by an attack that uses a vulnerability that he should have known about, or perhaps even knew about demonstrably. Okay. So in this study, we're looking at known vulnerabilities. And I'm going to talk a little bit about this. So suppose I have a new vulnerability I know about today, a new one. These vulnerabilities are assigned something called a CVE number, Common Vulnerability and Exposure Number. It's assigned by the US National Institute for Standards and Technology. Actually, I'm sorry, I take that back. It's assigned by CVE numbering authorities around the world. The dominant one in the US is the MITRE Corporation. But all of this is closely coordinated with NIST. So NIST maintains something called the National Vulnerability Database. So as soon as a vulnerability comes in, I need to know, is this vulnerable? If I'm a CISO, which is the putative position I put Rao in, I need to know, is this going to be used in an attack or not? If not, and I have a reliable predictor, then I can perhaps ignore it for now. As a cybersecurity guy, I can never say, please ignore a vulnerability. But as a pragmatist, I can say, for now, perhaps you can put it aside. The second question is, if it's going to be exploited, or the prediction is that it's going to be exploited in an attack, when and how severe? Can we answer these 3 questions? If we can answer these 3 questions, I don't know a single cybersecurity CISO who has all the resources he or she needs to do their job. They're all typically understaffed, overworked, huge scarcity of cybersecurity experts to work in companies, at least in the US, and certainly I think in India as well, most of the West as well. So you really can't handle everything as efficiently as you would like to. You've got to prioritize. Having the answers to these three questions is going to help that CISO prioritize. So we can try and predict these answers to these questions, but there's another very critical element to this. I need to predict it fast. There's no point if I wait 1 year and then make really good predictions. Okay? So most guys who are doing ML work will say, oh, I have this data set. I'm predicting X. But by the time they predict X, the attack is long gone. Okay, done. So, you've got to predict in a timely way, and that's got to be an essential part of the measurement of the quality of predictive performance that you're generating, but it's not. ML models today just say, oh, yeah, we got an F1 score, but F1 score doesn't say when you came up with the prediction. That's critical. So we want these predictions to be early, as soon as possible along this timeline, not further down. And basically, if I look at this metric, this is the predicted time to attack, and this is the predicted severity of a CVE. I can take every CVE that I know about today and put it in one of these 4 quadrants, right? So if I have a CVE today, I have a prediction of when it's going to be used in an attack and how severe, assuming it's going to be used in an attack. So I can put a little dot, and any dot that's up here is both going to be used soon and is expected to be severe. You need to deal with that now. Anything in this box here, maybe you can punt on it for a while. And anything here and here, you need to deal with it soon, but perhaps it's not as urgent as the things here, okay? So that's what we're trying to get at. And I'm going to take a specific vulnerability in a Microsoft Office memory corruption vulnerability. And on July 31st, 2017, in this case, MITRE created this vulnerability. So I don't know when they found out about the vulnerability, because they won't tell me. But I know from public sources that they had to have known it on July 31st, 2017, because they assigned that number on that day. And I know that from the public record. They may have known about the vulnerability for 3 months. If so, the situation is even more dire than what I'm going to show, okay? Second, they published it to their website on November 14th of the same year, about 3.5 months later. On December 5th of that year, NIST publishes information about the vulnerability. NIST analyzed the vulnerability, puts out this report. Most CISOs wait for NIST's report before doing anything. This vulnerability was exploited within a week of November 14th, okay? So that means before NIST put out their report, the vulnerability was already used in its first attack. So let me ask you guys a couple of questions. I have a pool of known vulnerabilities. What percentage of those vulnerabilities are used in attacks? Just take a guess. My data is from a 23-month study. 10%? 60? Anyone else? Okay, so you're almost right on target, okay? This is why you get paid the big bucks as director. So the number is actually 9.2%. Probably one of the few pieces of good news I can give you in cybersecurity, that only about 1/10 of the vulnerabilities that we know about are actually used in attacks. Does that help the CISO? No, because if he has 100 vulnerabilities, he's got to figure out which 10 of them are going to be used. So he's still got a problem. He says, okay, I only need to deal with perhaps around 10 of them, but which 10? That's why we want these predictions. The second question is, what percentage of vulnerabilities are used in attacks before NIST releases their report on the vulnerability? %2. Anyone else? 95%. Sorry? 80. Okay, sorry, PJ, I have to take the big bucks back this time. So this number is about 50%, okay? So almost half the vulnerabilities are used in attacks before CISOs start thinking about them. By the way, when I say used in an attack, I mean the date of the first attack anywhere, okay? So it does not mean your organization will be attacked, but somebody was, and it could be you next time, okay? So that's a huge percentage, and that's not a good state of affairs. So we built out a system called VEST, and just exploit it or not, we were able to generate F1 scores of about 99%. We were able to report on when the exploit would happen with an error margin of about plus minus 12 days. This is a mean absolute error. So if I predict that this thing is going to be exploited on June 15th, you can assume sometime in June, okay, with high probability. And the severity scores generated by NIST are on a 1 to 10 point scale. By the way, the severity scores generated by NIST have been the subject of much debate and argument and criticism. It's the best we've got, okay? So that's the one we use. But obviously the severity of a vulnerability depends on the target. If you have only one installation of that product in your network and it's in some isolated part of your network, you're obviously less exposed to it than someone else, okay, who's got that product everywhere. But we're using the intrinsic severity as measured by NIST as our dependent variable. That goes on a 1 to 10 point scale. Our error is about 1.25. So we predict it's 8, probably pretty severe, okay? So I won't show this video, but we have videos on everything. But this work, the flaw in this work was we were able to generate this. We were generating our predictions based on Twitter data, and we were able to do this only for about 2/3 of the vulnerabilities, okay? Because for many of these vulnerabilities, for example, there was no discussion on Twitter, so I couldn't even generate the features, okay, that I need to make the prediction. So we've been developing a system called NQs, the Northwestern Cyber Early Warning System. We're going to be putting this out publicly as well, sometime in the late summer, latest by September. And right now we're tracking data from GitHub, Reddit, and Stack Overflow, as well as Twitter. I'm a little nervous about Twitter, given all the upheavals there. But to show you some of these are our screenshots, show you some of our results. Will a CVE be exploited within N months using Reddit data alone? You can see that, you know, these numbers are all pretty good. Will it be exploited in the next month, sometime in the next 3 months, sometime in the next 6 months, etc.? These numbers are all pretty good, okay? Using Reddit data alone. Using Reddit and GitHub, similar numbers as well. Again, you know, generally F1 scores in the 99% range using GitHub alone. Severity scores are a little worse than the 1.25 I showed you earlier. These are our latest numbers, and it's closer to 1.4. Okay. Oh, well, you know, these are, as you can imagine, just cut and pasted. Yeah. Cut and pasted from a spreadsheet. Okay. We've also developed a number of techniques to estimate malware spread. So again, if you're the CISO, you know, what percentage of the machines in your network will be hit by this vulnerability? Okay, so we've developed an ensemble method that tries to answer that question. Again, our goal is to generate a set of products that will allow a CISO to make risk-related decisions, such as what do I do? Okay, so here again, we built a system called Cafe, and you know, again, some horrifying dates. These numbers are not from my studies, but from friends of mine who used to work at Symantec, and they therefore had a ton of data. So they showed that this is for a 0-day attack. They showed that on average, if your network is compromised by a 0-day attack, it's 312 days before you even know about it, okay? So that's pretty sad, okay? Even if they're wrong, the other competing studies from other big antivirus vendors put that number at least 250 days. I've not seen anything below about 250 days, all right? So regardless of which of these numbers is the right one, I think we can agree that they're all reflecting a pretty sorry situation. And then to make matters worse, even when a patch is available, organizations take an average of 4 months to patch. So if I'm an attacker, I don't even have to discover the vulnerability. I just have to know how to take a vulnerability that somebody else has discovered and conveniently put on the web. And I have to know how to weaponize. So that means that the barrier to entry for the bad guys is really, really low, okay? So we were looking at this question. I won't go through this, but we used a mix of cluster. I mean, this is one thing where every kind of machine learning was used to build out our predictive model to estimate the number of hosts. We had data from Symantec for this study, but the data they gave us was not enterprise data. They said, we'll give you data on machines and tell you which country they were in, but not which enterprise they belong to. So that's what we had. So we said, well, we're going to make these predictions on what percentage of machines in India will be affected by this malware. What percentage of machines in Brazil will be affected by this malware. So we had, I think, maybe 30 or 40 countries in our study. It was a pretty large data set. And we were able to, I'm not going to show you the screenshot of this. We've also been developing some methods to generate, allocate methods to, one, predict false alarms. So my CISO at Dartmouth was super cooperative when I was there. So he gave me access to his people as well as all the alerts that their security products were throwing up, and told me which of those alerts were false alarms and which ones were real. Okay, over 99% of the alerts thrown up by the security products were false alarms. And my hypothesis as a cynic, or let me just say as a cynical observer of the industry, is that the cybersecurity vendors did not want to be caught not having flagged a real attack. So they erred on the side of false positives than false negatives. They didn't want to miss a single real alert, so they just flagged way more crap as real alerts. And in the process, enormous waste of time, because you have to figure out what alerts to ignore and what to keep track of. So we figured out how to allocate, how to predict which alerts are real and which ones are not, based on the alerts thrown up by the security models. And then we also develop methods which say, well, if I have a limited set of people, how do I best deploy them in shifts so that I satisfy workplace rules and at the same time minimize the number of true alerts that are never seen by a security analyst. And then the sort of related question, if you're the CISO, is, what is the most important thing to a CISO? Okay, answer is keep security, real attacks down. But in fact, for most CISOs, the real question is budget. He cannot keep security attacks down without the budget. So he needs to be able to go to his board and his CEO and argue for a budget. So we also looked at the question, how do we, if I vary on the x-axis the budget that he's allocated, can I show on the y-axis what percentage of true alerts will never be seen? Obviously, as the budget increases, that percentage goes down. But what it allows him to do is to go to the CISO and say, look, if you give me another 5 million a year in budget or 20 million, I will cover far more alerts than I'm able to cover right now, because my current security team of 2.5 people can't deal with the large number of true alarms coming out. We develop that and generate graphs like this. And then we've got a large project on IP theft. We've all seen headlines like this. So our idea again is, fakes are my friend. Okay. So the question this is a project we've actually had for about 5 years, which says, if you're generating intellectual property for your company, can we automatically generate n fake versions of that document in which you're writing up your discoveries? Okay. So you're writing up so the vision we have is, the inventor is creating intellectual property for their organization. As they're recording it, think about saving it in Microsoft Word, but imagine that the save has a little piece of code between the time you write it, you press save, and this little piece of code kicks in and generates, let's say, 49 fake versions of it. And maybe you get a chance to look at it and say, okay, I think you can improve it this way. Obviously, the goal is to minimize the amount of work that the human analyst has to do in managing these fakes. So we want the fakes to be close. So if this is the document you're writing, I want the fakes to be close enough, that is within this red circle, to the original so that it's credible. Close enough according to some distance metric. But at the same time, not so close that it's correct. So I want these fakes to actually give me wrong information or give the adversary wrong information. So what happens when the adversary exfiltrates these documents through an APT, an advanced persistent threat attack. He sees 50 versions of the same document, doesn't know which one is real. And he's got to figure out which one is real. I'm not saying he won't figure it out, but I want to make him work hard for it. Okay. He's got to work his butt off to figure out which one is real. I'm happy with that because I'm imposing costs and delays on him. I'm also imposing frustration. I mean, how many of you are sick and tired of a paper you're writing by the time you finish it? You know, you've read it 20 times and it's just, you know, a big blur in your head. So we want that pain to be inflicted on the adversary. And then even if he chooses the right document as the real one, I want him to be unsure that he got it right. I mean, just imagine the manager asking his tech guys, are you sure? Are you sure? Are you sure? Okay, let's make him worry. Let's make them lose sleep over it. So that's the idea. The problem is that if I generate these documents this way and find K documents, which are in this sphere, in this red annulus, which are sufficiently different from D to be wrong, but not so different that they are not believable, then unfortunately, the problem is that an adversary can use common sense, okay, to at least eliminate some of these as the real document without really reading them, if he knows the parameters. So what we want is a way whereby if the adversary knows my algorithm, and if he knows the parameters of the algorithm, such as the radius of the inner circle and the radius of the outer circle, you know, he still can't figure out which the real one is. So I have to worry about an attack, an inference attack by the adversary, where the adversary knows the radii of the yellow and the red circle, and he looks at D3 and says, you know, if D3 is the true document, then this would be the inner circle and this would be the outer circle I draw around it. D sub K and D1 are not inside the outer circle. So D3 could not possibly be the real document, so he excludes D3. Everybody with me? So what I need is a way of generating the fakes. I need an algorithm that will generate it such that the set of documents, all K plus one of them, the K fakes and the D documents, generate exactly the set that I see, given the algorithm and the parameter, as in the radii of the two circles. They should both generate the same thing. That's what would prevent the adversary from eliminating some of these things as being the potential real document. So we came up with algorithms for this. I'm going to skip through some of this. We have a system for this. And then we have a large ongoing project on Android malware. I'm just wrapping up a book with folks from the Android security team in Google on predicting whether an app is goodware or malware. We look at manual analysis, machine learning based analysis, harmonize the two, look at specific categories of malware, such as spyware versus ransomware. And we've also got a number of techniques that we've developed to make it hard for an adversary to evade the classifiers. We don't prove theoretical results that say under these conditions he will evade it, because most of those theoretical results are not going to work in the real world because they make assumptions and use definitions that are not consistent with the real world. But we show that these adversarial evasion robustness techniques yield much better results against certain types of evasion techniques, at least in practice. And we've also developed a number of other things, such as, so the way malware also works is the adversary, the bad guy generates malware, right? He puts it out, and let's assume this is a criminal network. So it makes money for him for a while. Then the antiviruses catch on. They say, oh, this is malware. So what do? They block it. So what happens to the bad guy? His revenue goes down. He's not stupid. He realizes his revenue goes down. So he says, well, I have to do something. So he tweaks the malware to evade the defenses. And then the whole cycle continues. So Symantec came to us with a problem, which was, when we see a new malware sample, can you automatically figure out which family it belongs to? Because if we know that, we at least know who to send it to for analysis. And we know what signatures to modify. We know what other remediation measures have to be tweaked in order to accomplish this. So we developed techniques for that. I won't go through the details, but anyway, I'll stop there. Conclusion, AI is going to play a huge role in making the world safer, regardless of whether that's kinetic safety in the physical world, such as counterterrorism, or whether it's in the cyber domain. I haven't talked about the work we've done on things like generating influence campaigns, covert influence campaigns, etc. Obviously, those are all things that we're looking at, others are looking at. It's going to play a big role. So both on the attack side and the defense side, it's going to be huge. Thank you very much. I know over time, so sorry for that. So very good question. So let me start with the last question first, because I have a definitive answer to that, and perhaps less good answers to the other parts of the question. So the last question was, if all this is published, won't the terrorists respond appropriately to it, right? So the first person, the good news is I was asked this question before, and you're in good company. The first person who asked me this question was Tom Schelling. So Tom got a Nobel Prize in economics, one of the pioneers of using, I hesitate to say game theory, okay, but reasoning about games to make global strategic decisions. Okay? And he asked me the same question. And what we wrote a few papers which say, if you want to influence the adversary, here's the way you release the information that you have about them. Okay. So in other words, suppose I have findings A, B, C, D, and E about a group. Can I predict the response of the group if I release A, B, and C, but not D and E? Okay. As opposed to releasing C, D, and E, but not A and E. So we've got some techniques to do that kind of. But to make the findings we have accessible to those who do, or those who feel like they would be useful to them. Okay, and that involves a lot of different stakeholders. You know, different people have different attitudes to this stuff. So you can imagine that there are certainly people who are hostile to the use of any form of AI because, you know, they think it, as an example, takes away from their own power base. So they're worried about their own importance being diminished if AI techniques can be used. And of course, there are also, you know, colossal errors that in many of these groups. For example, the China work was done with the Dutch military academy as well, who understand, you know, war fighting much better than I do. In terms of being under pressure, you know, we're only using open source stuff, which anybody else can use. And then you started off with, you know, could this lead to the hegemony of certain nations who are capable of harnessing this technology? I want to say that I feel that AI techniques have been pretty well democratized by now. we are seeing the use of machine learning tools in virtually every country in the world, okay? And I don't think this is as the hegemony is going to be as skewed as you fear, because AI stuff can now be run on fairly commodity hardware. Yeah, if you want to train a deep neural network and need a billion data points and massive CPU, GPU computing facility to do it, maybe some of the poorer countries are left behind. But virtually most of the major nation states, at least those in the 70 or 80 most advanced nations in terms of OECD type numbers, they have this quite accessible to them. So it's perhaps only the smallest states, which may also be the ones that have the least to worry about being targets. Though some small states are targets of larger states. So yeah, I mean, so I worry less about that. There are always going to be haves and have-nots, and I don't see this changing that balance. We also know, as you mentioned, Boko Haram and technology. We know that a number of terrorist groups have used technology quite successfully. I am not aware of terrorist groups using ML successfully, but I am aware of terrorist groups, for example, using drones, okay, to launch attacks. ISIS is using it. The PKK has used it. Even the many of the militant groups in the Philippines have used it. State-sponsored groups like Hezbollah and Lashkar-e-Taiba are using it for sure. So, so I don't think terrorist groups or nation states are going to be far behind in this. So, yeah. So democratizing AI, I mean, I would say the fault for that is democratizing AI as opposed to leaving it in the hands of few. It cuts both ways. Yeah. There's no, I would say, clean answer, which sort of addresses, so perhaps various moral positions on this matter. All right. I'll let everybody go to dinner. Yeah, yeah.
Okay. Thank you so much, Professor Subramaniam, for your wonderful talk. I'd once again like everyone to give a huge round of applause for that amazing ending keynote speech. So we come to the end of all of today's sessions. As we wrap up the Kohli Day for 2023, there's a lot to think about when it comes to the value and importance of research and innovation. Today, let us reconsider these and look forward to the future, ready to take on some new challenges. So this is me, Orgo, signing up, and I say that too for my co-MC today, Nanda. And thank you and have a good night.